Ladies and gentlemen, distinguished speakers, honors guests, and also fellow innovators who attended both online and on-site, good morning, and welcome to the International Conference on Orange Technology. In my honor as both the representative of this conference and also the Dean of Faculty of Smart Technology and Engineering, Maranatha Christian University, to open this important gathering. Today, we unite scholars, researchers, industry leaders, and students who share a common vision to harness technology to uplift human life and strengthen social well-being. Orange technology, rooted in the interplay between human values and technological development, has never been more relevant than it is today. As we enter deeper into the era of AI, we are reminded that technology does not exist merely to automate tasks or accelerate computation. Instead, our technology calls us to humanize innovation, to design systems that empower, support, and enrich people. It asks us to consider how AI can enhance emotional well-being, strengthen community bonds, and improve accessibility, and also promote an inclusive future for us all. This conference serves as a platform to explore them in depth to interdisciplinary collaboration and also meaningful dialogue. As I prepared these remarks, I also acknowledge ChatGPT assistance in this remark. Its use reflects the very essence of what we celebrate today, the synergy between human creativity and intelligent systems, or AI. It is a reminder that when we use responsibly, technology becomes a partner that amplifies our capabilities rather than diminishing them. In the coming days, may you be inspired by the new ideas, challenged by fresh perspective, and encouraged to forge collaborations that advance Orange technology in ways that truly serve humanity. Together, let us shape an AI-driven future that is not only smarter, but also kinder, more inclusive, and deeply human-centered. Thank you, and I wish you all productive and inspiring conference.
Thank you, Mr. Oscar. Everyone, please applause. Next, we will hear the opening remarks from the Rector of Maranatha Christian University, Professor Insinyur Franz Umbudata, Master of Applied Science, PhD, delivered through a recorded video. Please direct your attention to the screen.
University, the host of ICOT 2025, to welcome distinguished keynote speakers, esteemed guests, fellow academics and researchers, honorable vice rectors, deans, directors, colleagues from the FPPM of Maranatha Christian University, ladies and gentlemen. It is my great honor as Rector of Maranatha Christian University, the host of ICOT 2025, to welcome all distinguished participants to the 2025 Triple IE 13th International Conference on Orange Technology. We are deeply privileged to host this globally respected interdisciplinary conference, where innovation, engineering, and human-centered design come together to envision technologies that elevate quality of life. Allow me to extend our highest appreciation to several world-leading scholars joining us today. Professor James Jingfa Wang, Distinguished Professor at NCKU and founder of the International Conference on Orange Technology. Professor Hapnes Toba, Professor of Information Retrieval, NLP, AI in Education, and Generative AI at Maranatha Christian University. Professor Yan Chun Sang, Distinguished Professor at Zhejiang Normal University, Fellow of the Royal Society of Medicine, United Kingdom, and the Emeritus Professor at Victoria University. Professor Paulus Insap Santosa, Professor at Universitas Gadjah Mada. Professor Si Pang Seng, Professor at Changzhou College of Information Technology. Professor Li King, Chair Professor of Data Science and Head Department of Computing, Hong Kong Polytechnic University. As host university, Maranatha Christian University reaffirms its commitment to advancing research that is technologically robust, ethically responsible, and socially transformative. I thank our vice rectors, deans, and the entire academic community for their unwavering support in preparing this conference. Orange technology at its core reminds us that innovation must remain human-centered. As AI and digital ecosystem reshape society, we must continue to design technologies that uplift, dignify, and empower. With deep gratitude to IEEE, the organizing committees, and all contributors, I am pleased to declare the 2025 IEEE International Conference on Orange Technology officially open. Thank you very much.
To open today's event with a rich cultural highlight, we present a traditional Indonesian dance performance by N Production. Please enjoy the performance. Give us a big applause for N Production for a wonderful performance. Thank you, girls. Before we continue, here are some quick technical reminders. Please keep your phone on silent and your microphone muted unless speaking. For everyone on Zoom call, please use the virtual background that is already provided and use the chat box or raise hand feature if you have any question or need an assistance. Before we start for the keynote and invited speaker session, we would like to remind you to attend or use the QR code above for the attendance form and check the rundown for today's conference on the QR on the right. Let us continue. Please welcome our first keynote speaker, Professor James Ching Fa Wang from National Cheng Kung University. Professor James, the floor is yours.
Okay, good morning, everybody. I feel I'm quite honored to be here to present my talk this morning. Okay, yeah. So we can open my PPT. Okay. I think today's my talk is concerning about the nowadays physical AI humanoid robot. And today I will focus on the design and application of edge computing systems for robot brain and cerebellum systems. I'm Jinghua Wang, an Archival Fellow from National Cheng Kung University, Taiwan. Next. This is my outline that divided into six sessions. The first one stage of the AI development, and the second is instructing the humanoid robot brain systems. And because we like to build our brain system on the humanoid robot, so we needed to introduce the edge computing devices the concept. And then when we build the humanoid robot system, I think it's a huge job. So we need platforms. And then we give you two examples to demonstrate our research on the deployment of each device on robotic brain and the cerebellum systems. And finally, I give the conclusion and the future work. Okay, next. Next. So I think we can review the evolution of the edge development, AI development. For the past, is perception AI. It's I think, for example, it's a CNN network for perception and analysis of the job. We call it a perception AI. And the second one is present AI, is generative AI and agentic AI. And now I think we will enter into the physical AI. This is the debate of humanoid robot. Next. So perception AI means understand, recognize, and interpret the various external signals or data. Its main goal is to mimic human perception abilities, such as speech or license plate recognition. And the second edge is generative AI. It can just analyze the work. It can create, generate, and simulate new content. Instead of simply classifying or identifying data, it produces entire new data based on existing information. And agentic AI also composed of multiple models. It can decompose complex problems dynamically, allocate computing resources as needed, and deliver precise response. And finally, the edge we are going to is the physical AI, no longer confined into the online or virtual world. It can perceive and understand the real world environment, enabling direct interaction with humans. So we have the real AI, just like the debug or humanoid robot. Okay, next. And for which AI, it means the age of humanoid robot is coming. And Elon Musk stated that in less than 20 years, the number of humanoid will surpass the human population by only 2040. There will be at least 10 billion humanoid robots. Now in our the world, the human being is about 7 billion, but the humanoid robot will be 10 billions by 2040. And the price will be between the 20,000 to 25,000 US dollars. The Jason Huang, CEO of NVIDIA, also pointed out that the humanoid robot will see a major breakthrough within the next 3 years, and will be ubiquitous within 100 years. Okay, next. So this is the photo of Elon Musk and Jason Huang. Next. And you will see that the humanoid robot will be everywhere because 10 million humanoid robot. Next. Okay, now we talk about how to build the brain systems in the humanoid robot. Okay, next. So this session we will divide into 2 subsessions. The first one is introduction function of human brain. We need to know what the human brain and the cerebellum, so we can simulate the robotic brains to the human brain and the cerebellum. And then we also talk about the architecture and module description of the robotic brain and the cerebellum. Okay, next. So I show here that the human brain function involves a wide range of activities from controlling the basic body process like breathing and heartbeat to complex function like thought, emotion, memory, and movement. Okay? And the major function of the brain are as follows. It's our thought and emotion, memory and learning, sensory processing, autonomic functions, and behavior and personality. And the main part of the brain, we have four main parts: frontal lobe, temporal lobe, and parietal lobe, and occipital lobe. So there are 4 main parts in our brain. Okay, next. And in addition to the brain, we have cerebellum. Cerebellum is a coordination, brain's balance and posture, muscle, tone, and motor learning. And coordination means ensure movement are smooth, like our hand and head. We have to ensure movement smooth and precise, coordinating skeleton, muscle activities, and also control balance and maintains the equilibrium, and regulate the muscle tone, help with the learning and perfecting new skills like riding the bike or playing a sport. Okay, next. And the main difference between the brain and the cerebellum is shown below. The main difference is that the cerebellum means brain handles conscious thought and higher level functions, while the cerebellum specializes in motor control and coordination. And the cerebellum is the largest part of the brain, responsible for reasoning, memory, and voluntary movement, while the smaller cerebellum, here, located at the back, and fine-tunes and coordinated voluntary movement, maintaining the balance and posture. Okay, next. Now we talk about our the structure and the workflow and the core capability of the robotic brain. So the robotic brain architecture simulates the brain cognitive cycles of planning, execution, and verifications. The brain plans and decompose complex high-level goals into subtasks, which are then executed by the cerebellum. And compared to the cerebellum element, the brain emphasizes strategical thinking, reasoning, and decision-making, ensuring overall task integrity and adaptivity. Okay. So, and then now we talk about the model. How do you deploy the model into the robotic brain? So VLM, we use VLM as the core model for understanding environment and language. It's a vision language model. It's an AI model that integrates language understanding with language reasoning together. So core of the brain, VLM serves as the central component of the cognitive brain. And also enhancing embodied intelligence, and also spatial and world understanding. So this is a VLM model. It's the core model for understanding environment and the language of the brain. Okay, next. Next. So we divide the three main foundation for the robotic brain. The first one is the large language model is the foundation for general knowledge, because we need a general knowledge for the humanoid robot. Like our human, we have a general knowledge to deal with the environment. So, so we have general knowledge capability. So LLM supply essential background knowledge for understanding, instruction, and performing language. And it's also a foundation for the multimodal intelligence. So they can speak, they can build. So we call it robotic vision and robotic language understanding and robotic humanoid robotic speech. Okay, next. The second main function is the task reasoning and decomposition. So chain-out sort. So with chain-out sort is the reasoning method that enables AI to think step by step by adding intermediate reasoning steps to input the prompt. The model can analyze problems more clearly and solve them more effectively. So the rollout chain-out sort in physical AI helps robot decompose task command into executable steps. Example, we like to do the fruit. So we see the robot sees the fruit on the table, and the reasoning that it should be picked up when they execute the action, object retrieval. So this is the chain-out sort can decompose the whole job into the subtask. So this is the second robotic brain capability, task reasoning and decomposition. And, okay, next. And the third one is the long-term memory ability, because we talk today, and sometime later we still remember. So this is we need long-term memory ability. So long-term memory is the core of physical AI's world understanding and experiential learning enable robot, not only to respond to command, but also to learn from experience. So it's not a response that the speech today, and he can respond the command maybe several days ago or sometime in the future. So the technical architecture, the memory system is structured into short-term, mid-term, and long-term layers for efficient retrieval and update across different time scales. So we have past time, current time, and future time scales. So it uses data, vector database, and knowledge graph to store semantic relationship, enabling context-based recall. So through keyword and semantic matching, the system retrieves relevant data to support the reasoning and the decision on different time scales. Next. So this is the system accessible long-term memory mechanism. So we have message coming, and we certain ways. We have a database and the passive database together, and then we can do some update place, and finally now we can respond the conversation for the past, currently, and the future. Okay, so this is the system architecture long-term memory mechanism, basic system architecture. Okay. Next. And then now we move to talk about the robotic cerebellum. And for the cerebellum architecture we're using another model called VOA, Vision Language Action. It's the core model focused on low-level control of vision language action integration. So through visual and language understanding, the cerebellum can transform simple natural language tasks into concrete mechanical actions. And compared to the brain, the cerebellum emphasizes speed and precision and ensure real-time and stable motor response. Okay, so this is the basic architecture of OpenVLA. Next. So overview of the VLA models, we have a vision encoder, language model, action model. And the primary challenge include effective vision of visual and linguistic information, highly complex action, space, difficulty in obtaining large-scale, high-quality training data, insufficient generalization capability. Okay. Next. And so we describe some detailed module of the VLA model here. So we have Dino V2 image visual expression, Sing Deep language image alignment, MLP project visual transformation bridge. Okay, next. Next, please. And we need the LM module. We can use Llama tokenized and text processing, and the Llama 2 and 7B language and action reasoning, and also action tokenized action decoder. Okay, next. And we compare some current major VLA model here. There is Google DeepMind RT2, Google Palm E, and Icot, and also OpenVLA. Next. Next. RT2 is a robotic transformer proposed by DeepMind. RT2 is considered one of the most mature and capable models for robotic action policy learning to date. Key characteristics is built on a transformer-based architecture capable of directly inferring action from language instruction and wide derived knowledge, support the general purpose robotic tasks, such as object grasping, cleaning, sorting, and categorization. Okay, next. And the Palm E is the integrated Palm large language model with visual module, and it's formulated as an embodied AI framework. Key features: strong linguistic reasoning capability, able to handle semantically complex tasks, and also support cross-model reasoning. Okay, next. Icot is often referred as a generalist agent, okay, capable of operating across diverse environment and control settings, such as Atari, gameplay, robotic manipulation. The key features are multitask and multi-model, and one of the earlier VLA-oriented model proposed in this research line. And OpenVLA is an open source action model, so it can gain the traction in the recent years. Emphasize trainability, transparency, and ability for practitioners to deploy and iterate on the system independently. So the key main feature is open source, so everybody can use OpenVLA. It's a model for the design of the robotic humanoid robot systems. So it's open source and highly customized and compatible with OS. It's a real-time robot operation system and real-world robotic platforms. And we are suited for research and prototyping. Okay, so this is the main and key features of OpenVLA. I think a lot of people, they use OpenVLA to develop their systems. Okay. Next. So we do summary, brief description of the brain and cerebellum. Brain also called cerebellum and also cerebellum. So brain system is a task understanding and planning. And cerebellum systems, action, execution, and control. So you can see the brain system. This is a robot, humanoid robot. We have a basic brain system and also cerebellum systems. And we have a four part. It is a frontal lobe, parietal lobe, and occipital lobe, and temporal lobe. And you see the cerebellum is a small part of our head. Okay, so the brain is a more big part, and the cerebellum is a small part of our human being head. Okay, next. Next, please. Okay, now I just finished to introduction the human brain and the cerebellum and also robotic design simulate our human being brain. Okay. And now we like to talk about the edge devices for building the robotic brain, because I think edge computing is very important, because when humanoid robot operate, we need some edge device on the head. So the key driving factor is for the edge device is latency sensitive application, because when you use the edge computing, you need to do latency efficient, and also model conversion and quantization and chip energy efficiency. So it's the three key driving factors. The first is latency sensitive application, and also model. We need a model compression or quantization technique able to reduce the model size, and also chip energy and efficiency. Okay, next. So one of the model optimization technique in edge computing is pruning. So by removing less significant or redundant connections with or neuron within a neural network. So like before pruning, we have a lot of connections. After pruning, we reduce some connections, but keep the performance. Okay, and we also like to do the quantization technique for the model optimization technique in edge computing. So quantization is converting the high precision floating point numbers, like floating point 32. That is a high precision floating point into the lower bit with integer, maybe integer 8. So from 32 bit reduced to 8 bit, and for enhance the efficiency and the speed. Okay, next. And now we deploy several edge computing devices into our lab. So for the NVIDIA Jetson Orange series, in 2023, there are some NVIDIA edge computing devices like a Jetson Orange series. So in 2023, NVIDIA launched the Jetson Orange series built on the MPL GPU architectures, offering 3 models that range from entry-level lightweight AI device to the high-performance computing platform. So the first one is Jetson Orange Nero, and the second one is Jetson Orange Mix, and the third one is Jetson AGX Orange. And in our lab, we use the Jetson Nero and the AGX Orange to develop our edge device on the robotic brain. Okay, next, please. And in 2025, NVIDIA also unveils the next generation flagship, that's Jetson AGX Soul, built on the Blackwell GPU architecture and designed to provide a high-performance edge computing solution for robot and embodied intelligence. So there's a high-performance AI computing up to FP4 gigaflow with sparse computation, and MIT support for real-time multimodal AI. And the memory and the bandwidth up to 128 GB and 273. Efficiency runs at 40 to 130 watt, offering 7.5x performance and 35 times efficiency games over green or green. And ecosystem fully support NVIDIA Icot and GRUD and related platform. Okay. Next. And we have to do some comparison for edge computing. That's Jason Nano from 2019 and Jason Orin Nano 2023, Jason Orin NX 2023. And the Jason AGX, now we have this kind of device. It's about 2,500 USA dollars. And now we try to buy the AGX Soul. It's about 3,500 USA dollars. This is the newest one for edge computing to design the humanoid robotic brain. Okay, next. So, and now I'd like to introduce some platforms for building the humanoid robot, because I just say humanoid robot brain system is a huge job. So we need some platform to facilitate, to increase the speed and design efficiency. So we need some platform for building a humanoid robot. And we'll introduce the four main platform here. Okay, next. So there are platforms for building humanoid robot. I introduced 5 humanoid robot platform here. One is NVIDIA, and the second one is Figure AI, and then Google DeepMind, and also iFlyTech. And the last one is S-Square Robot. Okay, next. And so the GR, maybe 002 or GRUD, we usually call it GRUD. N1 is a generalist robot, generalist. It's not a special robot, it's a general platform. Model able to understand language, perceive its environment, and autonomously plan and execute smooth actions. And they build 2 systems together, brain system and cerebellum and system together. So they are system 2. You can see the picture. System 2 and system 1. So system 2 is brain systems responsible for thinking and planning, focusing on understanding language and the environment to define the task. Okay, and also they have system 1, handles motion, execution, transforming the brain's plan into real-time, smooth robotic actions. So these are 2 systems together and for the group N1. Next. Next, please. So it's, the main features of group N1 is a multi-step task processing, equipped with long context reasoning. It can decompose language command into sequential action to complete complex tasks such as grasping and querying, and also complete the NVIDIA ecosystems. So not just this system is integrated omniverse, virtual simulator and collaboration platform, and also customers or model infrastructure to deliver a comprehensive robotic solution. Total. So it's the NVIDIA provides complete ecosystems to build the robotic brain systems. Okay, next. Next, please. And this is some demos for robot picking up various objects on the workspace, and also performing simulated making training. Okay, so this is the demo for Group N1. Okay, next. And then the other platform is Figure AI Helix. So Figure AI is an American company. They build a humanoid robot. I think it's now very famous in the world. And so they developed their platforms for the robotic, humanoid robotic design. So HEDIS is a vision language action, VLA model that enable the control our humanoid robot upper body, but they just control upper body through natural language command. And they also equipped two systems, brain and cerebellum collaborative architectures. So system 2, brain, runs pre-trained VLM at 7 to 9 hertz, responsible for language understanding and scene perception with a strong generalization across various objects and contexts. And system 1, we operate at 200 hertz using reactive visual motor strategy, converting system 2's semantic representation into precise and continuous motion control. So this is a Figure AI HEDIS system. Next. And execution speed and generalization, HEDIS achieve execution speed comparable to a specialized single task. Single task policies while maintaining zero-shot generalization, enabling it to handle new objects and scenarios. Efficient training and requires only about 500 hours of high-quality supervised data and to generate a full upper body humanoid robot. Okay, next. Next. So this is a demo. The robot picks up different objects according to their descriptions. Okay. Next, next one. And Google DeepMind also provides Gemini robotics. I think Gemini now is also very popular in the world. So Gemini robotics, they also have two systems, brain systems and cerebellum integration. Okay, next. Next, please. So video demo is almost, yeah, they also can pick items and play tic-tac-toe, open an envelope, play a card game, and close the zipper, yeah, and arrange alphabet letters. Okay, next. And the third one is iFly Tech. This is from China, robot super brain platform. And also they have a multimodal perception, the decision center, this is the brain systems. And also motion control and real-time response. So this is similar to the cerebellum systems. Okay, next. Key technique support long model, environmental, integrated software, hardware design. Okay, next. Next, please. And the last one is S square robot. Voila, A. So all A, this is coming from China. The first three is coming from USA, and this two is coming from China. S square robot. And there have the main features centers on the concept of large model plus fine manipulation. So like the brain and the cerebellum systems. Okay, next. Okay, next. Okay. Yeah, this is also the demo, like this cutting and also scraping powder with a spoon and then mixing it together. Yeah. Okay. And this is a combination of different platforms: NVIDIA, Group N1, Figure AI, HEDIS, Google DeepMind, Gemini, robotics, and iFly Tech, and also X Square robot, War A. So this is we describe some key features with the associated platform. Okay, next, please. And the first part of my talk is about our research, because in our lab we have doing the major research on the robotic brain design. So research is the brain systems. We deploying LM and NVIDIA Jetson AGX array to design a brain system. And we also have a normal mass target HAI for robotic fruit harvesting. So this is like surveillance systems. Okay, next. So research one is brain systems. So background is the large language model have demonstrated remarkable capability in natural language, understanding, reasoning, and generation. And despite this success, deploying LM on its device remains a significant challenge due to the constrained memory, limited computing resource, and strict latency requirement. Okay, so we designed this solution, our solution to address the retrieval accuracy, end-to-end latency issue. We propose papers and competitive LM-based hybrid RAG systems on edge devices. Okay, and the purpose of the mechanisms can be easily optimized and enhanced for a faster, precise response of appointed user domain on edge device. So we use some technique like dense retrieval, sparse retrieval, and cached retrieval. So we can be optimized for all merged to our satisfactory or appropriated edge AI chatbot. Okay. Next, please. So there are some related work here. Okay. Next. Next, please. And our method is based on the following features: dense retrieval, sparse keyword based retrieval, retrieval cache mechanism, hybrid ranking via top cache strategy. And also we do the Q-bar, Q4 context, LM for answer generation, and edge device deployment. Okay, next. So this is the total systems architecture. Next. We use a method is a dense retrieval, and okay, next. So the second is this is also dense retrieval. Okay, next. Next. Dense retrieval, okay? And also with Spark. Next, please. Sparse keyword retrieval. Okay, this is the second technology we used. Okay, next. Sparse keyword retrieval. Okay. And retrieval cache mechanism. Yeah. Next. Hybrid ranking. Okay. And quantization. Next. And so we use the ARIN and AGX, Jason Nano, AGX and ARIN NX and ARIN Nano, and we compare their features. Okay, and the next. So we do some experimental setup. This is AGX ARIN. And already now we use these two devices to implement the LM models. Okay, next. So this is some experiment. So we got better result for the employment edge device here. Okay, next. And comparison with other HLM system, we got the 83.6 accuracy, and A1 score is 69.3. Yeah, okay. So this is the best one. Okay. Okay. Yeah. Conclusion. So our proposed CLH RAG system addresses the key challenges of retrieval latency, memory limitation, and accuracy degradation in LM reasoning on edge devices. And the processing system achieve the highest retrieval accuracy and lowest inference latency on the NVIDIA JSON AGX or RIN compared with the current existing work. So provide a modular and scalable design suitable for future humanoid robot brain system or local knowledge assistant. Okay, so this is our first research. Okay, next. And this is reference. Next. And we also we like to the research tool is surveillance systems, new normal mass task HAI for robotic fruit harvesting. Okay, next. So we do the research on the fruit retrieval. So OCHA environment poses extreme challenge for robotics. Then there are some complex environment challenge in the OCHA environment. Illumination, so it's the first one problem. And the second one is occlusion and also clutter. So technical limitation, RGB dependency, simple fusion, and also localization. Okay, next. So we provide, next please. So there are the real-world application, full-scale testing and validation in real-world outchat and environment. And so we have this kind of robot. And now we have a project under the government polish. And we have designed this, and we have three professors, or two from the mechanical department, and one from double E department, so three professors together to do this real-world OCR deployment. Okay, thank you. Next, please. So measure overall system flow chart. Okay, next. So we have the system flow is a dual input, feature expression and cost model attention fusion, and also task specific head. So we recognize the type head, locate the position of fruit, and also ripeness verification, and the 3D cutting head. Okay. Yeah. So we demonstrate some traditional problems. Okay, next. So we have provided a method that's about uncertainty aware multitask learning loss function. So we propose the loss function. Okay. Okay, next. Yeah. So we have result here. The RDML and state-of-the-art SOTA achieved 97% and maybe at 0.5 and 91.5% F1 score on a challenging OCR data set. Okay, next. So the system achievement is we have state-of-the-art result achieved at more than 97% accuracy in one score. And also we do some practical HAI, deploy the model on NVIDIA JSON-oriented narrow, and demonstrate real-time inference and low latency. And visual implementation, the robot the robust perception backbone is ready for integration into function router, harvesting robot for real-world OCR deployment, effectively solving industry's labor shortage challenge. Okay. Yeah, so last, we do some conclusion and visual outlook. So in my talk, I provide several aspects demonstrated as follows. So I say the age of humanoid is coming. Oh, I think the world situation will be the age of humanoid robot age, and it will bring the new civilization to the life of human society. And the design concept and example of robotic brain and cerebellum using each device has been demonstrated. So we provide the concept and two examples to demonstrate how edge computing can be used, can be deployed in the robotic brain. And in the future, I think more companies, more money, and more people will be invested to fulfill the human robot entering our real world in less than 10 years. So this concludes my talk. Thank you very much.
Thank you, Professor James. Everyone, please give another applause for the insightful presentation. For our next invited speaker, please welcome Professor Li Qing from Hong Kong Polytechnic University joining us online. While we wait for Professor Li Qing, well, let's open for a question and answer session for participants in here and as well as from Zoom online meeting. If you guys have any questions regarding the previous presentation from Professor James, you may raise your hand. After this, yeah. Yeah, feel free.
Yeah, reference, yeah, reference verification, and also position verification, and also the pickup point. Yeah. Color and the depth, color and the depth, both, the two input, two kind of input, yeah. So we have a cooperation with some farmer in Taiwan. Yeah, and so we have do some real world experiment. Yeah, this year. Oh, next time you come to Taiwan, we can show you. Okay. Yeah. So we also designed a robot. That's from the professor in mechanical department in NCKU. Yeah. For the robot design. It's just a project from the National Science Council. Yeah, and we like to be applied in the real world. Okay. Thank you.
Any other question, perhaps? From here or anyone from Zoom? If you have any question, you can raise your hand. Okay. Okay, once again, thank you, Professor James, for the insightful presentation. We would now like to invite you to the stage to receive the certificate, which delivered by Professor Dr. Setin S.A. MSE AKCA, Vice Rector of Academic Affairs, Research and Community Service. Professor James, you may also go to the stage. Professor James. Let's give another applause for Professor James. We will now like to have a group photo Ladies and gentlemen, please remain seated and look forward to the stage as the photo will be taken from here. Everyone who is sitting on this side, please move to the middle section so we can have a nice looking photo after this. Thank you. Just stay here. Oh, yeah. Okay, everybody look at the camera, please. 1, 2, 3, cheese. Another one. 1, 2, 3. All right, thank you, everyone. Okay, do we have Professor Li Qing on the line?
Can you see me?
Okay. For our next invited speaker, please welcome Professor Li Qing from Hong Kong Polytechnic University joining us online. Professor Li Qing, please begin at your convenience.
Okay, great. Let me share my screen. So can you see my screen? Can you see my screen now?
Yes, we can hear you.
Okay, thank you. Uh, there seems to be some echo. Okay, good morning. So very happy to have this opportunity to share with you our ongoing project, multi-level pairing method for indoor robot smart space. So I'm Jimmy from Hong Kong Polytechnic University. And my talk will be in the following 6 parts. I'll briefly introduce the background of this project. So first of all, what is smart space? This actually different people may mean different things. To us, a smart space means a dynamic, adaptive environment enhanced with robotics and AI. So examples of smart space such as smart home, smart office, smart cafe, etc. So why smart spaces matters? Okay, why it's important and useful? Technologically, it integrates different technology like computer vision, natural language processing, AIoT, data mining, recommender system, sympathetic computing, etc. The aim is to improve efficiency, personalization, and guest satisfaction for seamless interactions. So for that reason, it echoes on the theme of this orange technology to make people satisfied or make people happy. So the objective here is enhance user interaction with good experience, improve user satisfaction level, optimize space usage, and by leveraging AI technologies. So here's an overview example of what we call smart space here. As you see in the center, there's a robot or robot with an arm, and the users interact with the robot through digital avatar or digital human, and through interactions, robot will provide a service to the user. Okay, will deliver the service. So some of the key challenges of such a smart space environment, including a complex environment, because this is not a single user or single object environment. It can be working in a busy space where things keep moving or changing, and also finding the right balance between what people want and what's really good to them in terms of health is also an issue, because you want to make people happy, but you also want to make them happy in a healthy way, right? And group interactions, make sure the system can work well with many people around, okay? And handling different type of data, because the data come from multi-source. It's a multimodal, multi-source data. So as I mentioned earlier, in this project, we employ different technologies such as AIoT and natural language processing, computer vision, and robotic control, and also health computing. Be aware of the health issues. So how to enable smart space by integrating those different technologies, okay? As I mentioned earlier, that's one question we need to handle or tackle. And for that reason, we proposed PolyRack, which is a multi-level knowledge pyramid, okay, for question answering. So this is, as you can see, if we move up from the lower layer to up layer, it is moving from more general foundation model or foundation knowledge to more specific domain knowledge, okay? So we have the foundation layer, data layer, information layer, knowledge layer, and wisdom layer, okay, or ontology layer. So that the reverse, of course, is to move from more specific knowledge domain to more general domain, but with more noise or hallucination. In the traditional approach of RAG, this is one way to incorporate external knowledge or external data from domain-specific database, which is through indexing, convert to a vector database, the user query on the vector database to do data retrieval and generation. So this is like a traditional way which involves massive amount of data to improve the coverage, but it is essential to be able to balance between recall and precision, because less accurate if you apply to a specific domain in the previous pyramid. So this is pyramid construction. How does it work? Okay. In our approach, user query will be first processed at the ontology layer. Okay, so the data format will be ontology schema. So in this way, if the user query can be handled directly or accommodated by the ontology schema, then it is great. It is more preferable because knowledge is more specific and also more accurate. It's validated by domain expert. If not, then we can move on to the next layer, which is the knowledge graph layer. So which the data format is a triplet, right? So we will have the head and the tail, and we have the link, okay? We have the relation. So the node, head and tail, are all knowledge nodes, right? Or concept node. And this is their relationship, okay? So this layer is also of high quality, okay? Because it's although it could be semi-automated, in terms of knowledge graph generation or even fully automated, but users still would verify the correctness of the knowledge graph by domain expert. And the third layer is the naive, the rack layer I just mentioned earlier, by incorporating external knowledge from different domain through the rack process. So how do we encourage these interactions between among layers? Okay, as mentioned earlier, the wisdom or ontology layer, the advantage is that the data is highly formatted and precise, but the disadvantage is the scope may be too narrow. Okay. So if you look at the move down to lower layer, it would be broader contents in terms of scope, but maybe start to introduce noise. And the information layer, which is with the help of a rack, okay, all knowledge we had would be supposedly available here, but maybe containing too many noise. Okay. So how to improve this? Okay, we facilitate the interlayer interactions. For example, I use knowledge graph. Okay, this blue line, the purple line is to expand the ontology layer. Okay, through the knowledge graph repository. Okay, by adding more ontology. This is called a knowledge completion process. Whereas if you go the backward, okay, use ontology to restrain the knowledge graph, remove noise, knowledge graph triples, okay, obtain higher quality knowledge graph. This is called knowledge condensation. Okay. So actually both both steps are useful and helpful to smart space applications. So let's look at an example. How can the ontology be extended? Okay, so this is by looking at the query and also comparing the schema, ontology schema, and with the knowledge graph facts. Okay, when we found that the blue part is the initial ontology knowledge, and the red one are the result of knowledge completion, the knowledge expansion from the knowledge graph, maybe in the form of knowledge completion process or query process. Okay, dynamically adjust the ontology. So, for example, the user query, okay, may ask which staff in CS department graduate from MIT. Okay, so this is the query against the ontology schema, and this would be first processed directly at the schema level, at the ontology level, and if the answer, okay, if it match with the knowledge contained here, then you do not need to go to the lower layer. You can just skip the knowledge graph layer and directly output the result. Okay, so this is the simple case where the query can be directly handled and covered by the top layer. If we look at another query, what are the research interests of user, of a particular person, Alice? Okay, notice that Alice actually was included in the top layer, but with limited information or knowledge. So this query, what's the research interest of Alice? Okay, you may find there's no hit, okay, no match in terms of research interest of Alice. So that means we need to go to a lower layer, okay, go to the next layer to find out whether this knowledge graph layer would contain any information about Alice's research interest. And so we move on to the knowledge graph layer, okay? And we found this in the knowledge graph, we do have a matching of Alice has the interest of AI and machine learning and data mining, etc. Okay? So in this case, the answer, the query can be answered by accessing this layer, okay? with the right answer. So in the general method works, okay, in the multi-layer query paradigm as follows. So upon receive a query, right, we will try to search from the ontology layer, okay, to see whether it has any answer readily available. If not, that means no hit. It will go to the next layer. There's a knowledge graph layer to find whether there's any answer, okay? And if not, still not, we move down further down to next layer, the information layer, or called the RAG layer. So to get the knowledge from the external domain-specific database, okay, as I mentioned earlier. So this way, we will hopefully have the answer fit into user query and generate with LLM inference in context, we generate the output. Okay, so this is the multi-level query approach that we are adopting. Now, how it works? Okay, we show some preliminary results. How does PolyRag perform compared to other baseline? We have compared with a direct query, in-context query, knowledge graph augmentation, okay, and our PolyRag approach, okay, and based on this different benchmark, okay, and actually we have seen that no matter which underlying the underlying large language model based on, okay, with the pyramid approach, in terms of F1 score, okay, and the precision or recall score, it is the best, okay, and this is a blue, okay, this is to measure the smoothness or naturalness of the answer, and where approach is pretty reasonable. And this is the impact of completion, knowledge completion, and the condensation through F1s. And also our approach performed well under on top of different large language model as foundation model. And here's a evaluation study to show those different components with the ontology and knowledge graph, or without ontology, but only with the knowledge graph and the raw data, that the RAG, okay, and et cetera, et cetera. So actually it shows that the best performance come from all the components being incorporated naturally, okay, for on top of different large language model, this similar performance behavior. So what can this PolyRag do in the environment of smart space? Okay, so as a pilot study, okay, as a showcase, we implement our PolyRag in the context of a coffee machine, coffee robot environment, okay, to tailor user preference and health needs. Okay, so here's the main flow of the coffee robot system. Okay, so this first user need to register at first time. So the system will know you, remember your ID, your face, okay? So first time you do need to do face recognition and go through the this identification process. But this is only for the first time. The second time you do not need to repeat this again, okay? So this is for entries workflow. And the second component is a call to the bar, okay? So this way we want to have a guest face displayed on the bar screen, okay? With clear communication and navigation assistance and autonomous navigation facial recognition. okay? Uh, and this is a corresponding workflow, okay, call to the bar step. And the third step is make a recommendation, okay? Through interactive chatbot, okay, user can discuss preferences with the system, the robot, okay? And robot will collect mood, taste, and diary input and make suggestions, okay? This is a tailored recommendation with explanation why it is good for you, for the user. And of course, user have a final say to accept or to modify. Okay, so those are some example dialogue, which we're going to show some demo very soon. This is a corresponding workflow on the recommendation procedure. And then the next component is serving coffee, right? So this is a serving component. Need to prepare the coffee, and also while the user is waiting, may want to interact with the user with some entertainment or interesting conversations. Okay, and then finally deliver the coffee to the right spot to the user. Okay. Correspondingly, this is the flow chart of the workflow for the serving and the interaction part with the user. Okay, so let me now show some of the short demo, how you see how it works. This is a virtual avatar, okay? This is the robot. Sorry, I think I. Chocolate order received. So this is a direct input. The user wants a chocolate cup.
My name is Mike.
So this is a virtual robot. This is a real robot arm here, okay, to serve the
Chocolate assigned. Your order is placed. I'll call you when it's ready. Feel free to take a tour in the smart space.
So it will pick the right coffee since the user explicitly asks for chocolate. Yeah.
Order chocolate finished.
You can also change the digital avatar to be any favorite figure you like. For example, instead of the girl, you can have this movie star, etc. So I will skip some because it's basically the same functionality in terms of receiving the order.
Have a great day.
Yeah.
I've been quite stressed.
No, this is related to health related recommendation. Okay. So the user say he's in a stress mood, asking for what recommendation good for user.
Chocolate can be a comforting choice for stress relief, as it provides a warm and soothing experience. However, it's high in calories, so you might want to opt for a lower calorie option like white coffee made with skim milk.
Okay, so it provides the recommendation with explanation why it is a good choice for the user to consider.
I have a friend.
In another scenario,
Very energetic. Would you recommend a cup of coffee?
so this, we'll try to speed up a little bit. So
Yeah.
the user is and difficult to sleep.
My recommendation is to see a doctor or engage in more physical activity before bed to promote relaxation.
Again, with good explanations.
What is your name?
So this is just for casual chatting or random chat. So if the user waiting for coffee to be made,
Preferred, call me Taylor Swift, as she is my favorite singer.
What's a boring day?
for
Can
entertainment.
we do something to kill time?
So I think the system. Okay, let me. This is trying to make a joke with the user.
I don't know.
No idea.
Okay, you're so tricky.
So she's making a joke, asking.
Would you like to try it again?
Yeah, sure, why not?
Okay. What do you call a bee from the America?
So this is just another joke for the user to.
Beef from America? I don't know.
The answer is quite interesting.
Bee.
Okay.
So actually, we showcase this to a lot of visitor and audience. Okay, before I show you those pictures, the coffee robot can also answer domain-specific questions. That means questions that are only applicable to particular environment. For example, in my campus, right? So.
Do you know any professor from School of Accounting and Finance who also interested in artificial intelligence?
So note that this query is requiring the RAC, the external database information.
According to my knowledge, Professor Jack Poon from the School of Accounting and Finance at PolyU has research interests in artificial intelligence. He has published several papers on the application of AI in finance and accounting, and has also taught courses on AI and its applications in the industry.
So this obviously is not a general kind of fact, but specific to a particular domain.
Is there any
Here's another example.
School of Design who is interested in applying technology in their artworks?
School of Design is one of the school in my university. So she's looking from the top layer to lower layer to the rack layer.
Taylor, professor in the School of Design, is known for his expertise in applying technology in his artworks. Additionally, Benny Leong, a professor of design practice in the School of Design, is also likely to be interested in applying technology in his design practice.
So both examples shows the access of information at the.
Are there any professors from the Department of Mechanical Engineering who is also a member of the Hong Kong Institute of Engineers?
So these are all very specific terms, terminology.
I found that Professor Mak Chuk Ming and Professor Neo Jian Lei are members of the Hong Kong Institution of Engineers. Both of them are affiliated with the Department of Mechanical Engineering at PolyU.
Do you know any professor who graduated from the University of Cambridge and now is a member of the English Language Center at PolyU.
Okay, so this query combines search condition with two conditions. One's graduation from Cambridge, one's currently a member of Language Center.
We use staff in the Department of English and Communication at the Hong Kong Polytechnic University. Moreover, he graduated from the University of Cambridge, and he is a member of the English Language Center at PolyU.
So that means you can add a lot of conditions to let the robot figure out the right answer. Okay, so as I mentioned, our demo actually is very well received by visitors, particularly kids, students from high school and undergraduate. They're really interested in this kind of human-robot interaction with actions, with services performed. So many groups actually came to our lab to look at, to experience this kind of human-robot collaboration. And we did some small data analysis based on user feedback. Okay, so on the in terms of sentiment analysis and trend visualization, this is an average rating score of service improvement. Out of 5, user give 4.5, okay, stars. So with a satisfaction rate around 95% based on the feedback. And also we have the 3 matrix used: rating, popular choice, area for improvement, with a quite encouraging results. So in conclusion, the key takeaway include the following. We believe smart space, combining robotics and AI, can provide superior experience, user experience and services. And we need to leverage and integrate different technologies like computer vision, NLP, AIoT, data mining, synthetic computing, recommender system, etc., to provide efficiency, personalization, and customer satisfaction with seamless integration. So, of course, this project is currently still in the early stage, and we really invite collaborators from all over the world to collaborate with us in this smart space initiative. Future direction including first, we want to expand user cases to not just coffee robot scenario, but more broad areas such as healthcare, such as retail or class education in the education domain, in-class education. And also technology-wise, we need to further improve the interaction, the accuracy, and the efficiency, and scalability, okay, and also sustainability. Okay, so yeah, this project has a large team of professors from my department, including Professor Wei working on computer vision, Professor Maggie Lee on natural language processing, and Professor Zheng working on AIoT, okay? And the project was funded generously by our university. So with that, I thank you for your listening, and questions are welcome. Thank you.
Let's give an applause for Professor Li Qing from Hong Kong Polytechnic University. Thank you, Professor.
Is there any questions?
Yes, for everyone who participates here in the room or joining us on Zoom, if you guys have any question, you may raise your hand. Yes.
Hello, Professor Lee. I have a question. I am very interested about your multi-layer rack structure. The top is the ontology layer, and how to, your ontology structure is how to generate. Yeah. He is predefined by human or he generated from the knowledge graph. Yeah.
Actually, it is initially is defined by human. Yeah, but it can be refined through knowledge completion process to be expanded if need. As I said earlier, the interaction with the knowledge graph layer can help expand the scope of the ontology, but with the user confirmation, with the user's validation. Yeah.
All right, thank you, Professor Iching, for the answer. Maybe any other one? Any other question? If there is none, once again, thank you so much, Professor Li Qing, for the insightful presentation. We will now like to invite Miss. Oh, oh yeah.
Hello, Professor Li Qing.
Yes.
Can you see me?
Yeah, I can hear you.
Oh, okay. Yeah, it's a long time not to see you. Yeah. So your report is very interesting. And I wonder, because you said a good job in Hong Kong Poly U, right? And your system wants to transfer to another area. So how do you estimate how much time you need to transfer your system to the other places?
Yes.
Okay.
Very good question. Thank you, Professor. Professor Wen. So this is basically currently a small toy, I would say toy application in coffee robot domain. But in fact, if we transfer this to other domains, including, for example, healthcare, or including, the maybe grocery store like 7-Eleven, right? So I mean, there are many scenario we can transfer into. So long it is equipped with those IoT and the computer vision sensor, etc. But the key, I think the key difficulty is you need to inject the local database, okay, the domain-specific data. You need to build the new ontology for the new application domain like healthcare or the the supermarket or grocery store scenario. You need new data. You need a new domain knowledge, and on the ontology and the knowledge graph. So this process of the knowledge engineering part actually takes quite a long time. The good thing is currently the large language model, the foundation model, is very powerful, but still it is in terms of application domain specific knowledge, it is very weak. It is a very I would say noise, contain a lot of noise. Yeah. So this is the main part is of course the hardware part is also important. The integration of the hardware, even as you see from the demo with the small robot arm control, actually it took us a long time to do the testing, to do the all the experiment. But the student love it. Okay, our young student really like to work with hardware as well, not just software. So this is a good part of this kind of a project. Yeah, but overall it takes quite a long time to get familiarized with the control unit of the robot arm, and also how to combine the vision. It has to know which button is where, corresponding to which function, which choice, and also we want to later incorporate sentiment-aware recommendation. That's even more challenging. Yeah. Thank you.
Thank you, Professor.
Hi, Professor Lee. It's Yan Chun. I have a really quick question. It's a really interesting talk. Both you and Professor Wang talked about robots. Yeah, that's hot topic. I noticed that you mentioned in the application in future you're thinking about in the healthcare area. But I know in the natural language understanding, if your accuracy is about 50, 70% accuracy, is pretty good, yeah? But in healthcare area, if your accuracy is about 80, 90, but it's still this issue, yeah? How do you comment on this part? In healthcare, we need a really high, and also this response for the health issues.
Yes,
Okay.
very good question and very challenging indeed. I think healthcare is also at the same time broad area. There's many issues related to health. Happiness is one of them, right? We want to keep people from the bad mood, turn people from bad mood to good mood, to happy mood. So I think in terms of you mentioned about the current limitation of large language model for healthcare. If you use directly for healthcare, it's certainly not acceptable. Yeah, I think for our project, we do not aim that high as a professional solution. It is a more, I think, a supportive solution. So, for example, if I can help those depressed people or mentally disordered people to some level, to some extent, be able to comfort them with more pertinent recommendations and also chattings. So be able to comfort them to some extent. Okay, I think that would be our first initial goal, first step, okay, towards the healthcare application, which is big application. And I think I know you've been working in health informatics for a long time, so I think it would be good for us to learn from your experience what kind of factors and issues or pain points that you guys are facing, and what robot and embodied AI can do to help alleviate some of or mitigate some of the pain points. Yeah, that's our general wish. Okay, but I'm not sure how far we can go on that line. But certainly, it's a very important area.
Thanks. Yeah, the first start to aging care for elderly, the comfort is more important. Yeah, thank you very much. We can talk later. Yeah.
Okay, so is time up? I forgot what is the time now. But yes, so unfortunately, I could not come to the conference on site to interact with you guys, but I hope to be able to catch up next time. Yeah. And thanks for the invitation, Professor Wang.
All right, thank you, Professor Lee. Everybody give applause for Professor Lee. Since Professor Lee joining us by online, for the certificate session, we would like to invite Mr. Emil R. Kaburan, PhD, on behalf for the certificate memorial session. We would like to invite Professor Dr. Setin S.A. MSc AKCF as Vice Rector of Academic Affairs, Research and Community Service. Okay, thank you. Once again, give another applause for Professor Lee. Thank you, Professor. We will now have a short coffee break. Please enjoy the refreshments that have been prepared on the right side from this door. We will resume the program in 15 minutes, so kindly be back on time. We are kindly also reminding you to scan the QR code for attendance form and to check the rundown for today. Thank you. Untuk para peserta boleh bisa menikmati snack ada di bagian kanan dari pintu. Ada kotak yang disediakan untuk para peserta. Terima kasih. Test. Ladies and gentlemen, the break has now concluded. We kindly invite all participants to return to their seats as we are about to continue the program. Another reminder for everyone who is still outside, we kindly all invite all the participants to return to their seats as we will resume the program. While we wait, don't forget to scan the QR codes for the attendance and also for the rundown. bit.ly attendance dash sesi 2 and bit.ly/rundown dash ICOT 2025. Okay, now that we have everyone back on their seats, let's welcome our next keynote speaker, Professor Dr. Hafnes Toba, MSc from Maranatha Christian University. The mic is yours, Professor.
So, good morning, everybody. Can I just start it? Oh, okay. So, thank you and welcome for all of you. It is an honor to share my opinion in this year's International Conference on Orange Technology. My name is Hafnes Toba. and I am a member of the Intelligent Informatics Research Group at the Faculty of Smart Technology and Engineering, Maranatha Christian University. This talk reflects on how educators, I believe we are all educators, can guide humanity wisely in an age shaped by intelligent machines. I think this topic fits the central theme of Orange technology. Next. I believe that AI should serve human flourishing and not to compete with it. And today, we will explore how to draw new maps for navigating the digital continent, maps that help us stay connected for meaning, responsibility, and humanity. Next. So, where are we right now? As we know, AI systems now perform tasks once reserved for human minds, summarizing documents, diagnosing, analyzing, generating text and images. And this brings us to a fundamental question. What does it mean to be human when machines imitate thinking? For educators, the tension is clear. Our expertise is no longer unique. Our empathy becomes even more important. Machines resemble collaborators rather than tools. And this revolution is unlike any other industrial revolution because it blurs the boundary between human judgment and machine output. You can see at the image on the right side how we evolve in the education world today. The image captures our shift from traditional learning spaces to algorithmic networks once. So you can see below is the traditional way and above is the modern way. The classical classroom symbolized stability, structure, hierarchy. But today, we teach and learn in an algorithmic agora, that is a digital public space, mediated by platforms, feeds, and adaptive systems. And this transition is not only technical, it reshapes how knowledge is created, shared, and valued. Next. So there are three main agenda in this session that summarize my approach when preparing this talk. The first one is a kind of literature reflection, and the second one is a proposal about a five-dimensional awareness. And the third one is some research examples that our team have done to show how the proposal works in its implementation. Next. Our research today, or our reflection today, are drawn from three main resources. The first one is this. It is a scholarly journal entitled, "Do We Still Need Teachers?" It's navigating the paradigm shift from teachers' role in the AI era. Next. And the second one, it is an apostolic letter from Pope Leo XIV, which challenges educators to draw new maps to hope. And the third one, next, it is a contemporary opinion view that expertise is becoming a commodity. It is easily reproduced by machines. And together, these perspectives help us to understand the cultural, pedagogical, and philosophical shift we are experiencing. Next. So traditionally, teachers transmitted knowledge, but AI now transmits knowledge faster and on a huge scale. So, the teacher's mission evolves from giving information to forming an interpretation, to helping learners discern and humanize knowledge, and teachers as AI literacy architects. In the AI age, transformation, not information, is our true responsibility. So teachers guide meaning, ethics, depth of the knowledge, and as literacy agency. Next. We are not patching the old system. We have the duty to draw entirely new maps. Education must chart new roads through digital identity, algorithmic influence, ethical responsibility, human relationships mediated by technology. And we want integral education. Our challenge is to offer maps where students don't get lost in the digital continent. Next. And this is the main alert. AI make our expertise as commodity. AI often performs expert tasks, writing, coding, analysis. And this shifts expertise from human craft to market commodity. And there are two dangers, in my opinion. The first one is we begin to trust algorithms more than human judgment. And the second one is that we undervalue our own deep embodied lived expertise. And as educators, we can compete with AI in information delivery. But we are excel in interpretation, moral reasoning, contextual understanding, and care. That they are the capacities that no algorithms fully replicate. Next. So in the classroom, infused with AI, the teachers become, first one, a witness to meaning, the second one, guardian of discernment, and the third one is a guide who reminds students that not all information is equal. So I would say that data without discernment is noise, and intelligence without virtue is danger. Actually, our situation has been foreseen in 1992 by a professor, Neil Postman, who wrote a book entitled Technopoly. So in this book, Neil Postman writes that a culture that surrenders its moral direction to its own instruments, and it is very dangerous. The book is published in the beginning of the internet era. And what is Technopoly actually? You can see, next, sorry. And next. You can see in the right side that Technopoly creates a society overwhelmed by information, where an excess of data reduces the capacity for deep reflection and critical thinking. That is, we are now. And the second one, Technopoly means technology reshapes institutions like schools and media, turning them into mere distributors of information rather than guides for understanding, meaning, and moral orientation. And the third situation in Technopoly is that the real challenge is restoring balance, ensuring that technologies serve human values rather than dominating them, so society can remain thoughtful, meaningful, and morally grounded. So this is already foreseen about 33 years ago. Next. And now let me briefly walk you throughout the 5 dimensions of our framework, the 5 lenses that help learners navigate a world shaped by AI. The first one is technical dimension. Students today don't just use AI, they learn with it and about it. This means developing data literacy, understanding algorithms, recognizing bias, and practicing ethical coding. We need students who are not only consumers of AI, but informed co-creators who can question how system works and why they behave the way they do. The second one is the emotional dimension. As machine simulates empathy, human authenticity becomes even more important. Students must learn how to remain emotionally grounded, how to build real compassion, sustain healthy relationships, and contribute to community engagement. Emotional intelligence is no longer optional. It is the counterbalance to artificial responses. The third one is the social dimension. Technology is never neutral. It is a social construct shaped by human values, culture, and power structures. Student needs to understand that data can encode discrimination and algorithms can reinforce inequality. This awareness helps them see AI not as an objective authority, but as a human-made system requiring oversight and justice. The third one is social dimension. The fourth one is the spiritual dimension. Here, spiritual refers to meaning, purpose, and inner orientation. AI invites us to practice cognitive humility, the recognition that our intelligence is limited and that discernment is essential. Students must learn to pause, reflect, and ask, is this good? Is this true? Is this humanizing? Discernment is the moral compass in an algorithmic world. Finally, the fifth one is the ecological dimension. AI is not abstract. It has physical footprint. Large models consume massive energy, water, and computing infrastructure. Students must see environmental stewardship as part of digital literacy. Understanding that every query, every questions, every model has ecological consequences. Sustainability must accompany innovation. Together, these 5 dimensions, technical, emotional, social, spiritual, and ecological, form a holistic map that guides learners to dwell wisely in the digital continent without losing their humanity or their responsibility to one another and the planet, our Mother Earth. Next. In the next few slides, I want to share how we could implement those 5 dimensions in our educational AI research. So this comes from our research. Our first study, entitled Groups Allocation Based on Sentiment Epistemic Analysis in Online Learning Environment. It is an intelligent grouping algorithm that combines sentiment and epistemic level analysis to create balanced collaboration among students. It interprets affective and cognitive signals to encourage empathy and inclusivity in groups dynamics. We use here the forum textual data and create a kind of epistemic network analysis and sentiment analysis model. And our first study shows that how adaptive learning can personalize pathways based on learner behavior and engagement. AI helps differentiate without overwhelming teachers. Next. And this is the second research that I want to share, entitled Bloom Epistemic and Sentiment Analysis Hierarchical Classification in Course Discussion Forum. It is used to identify the cognitive and emotional depth on online discourse based on Bloom taxonomy. So teachers can interfere not only just using grades, but also on students' learning pace and growth by analyzing their comments in course forum. And what we learn here is that we highlight how AI provides real-time formative feedback and supports cognitive structure that assists slower or struggling students. Next. And this is our third research that I want to share, entitled Large Language Model Question Generator based on Bloom's taxonomy template. So AI is used here to generate questions and automatically grade the answers. And what we have learned here is that AI can inspire, not automate intellectual formation only, but also it creates innovation which harmonize analytical precisions with ethical intention. Next, and this is the next research that I want to share, entitled Machine Learning Models to Detect AI-Assisted Code Anomaly in Introductory Programming Courses. We want to extend here about moral dimensions of academic integrity. So we create a system that AI would detect formative feedback mechanisms which help students to develop with self-awareness in their learning process. We examine here risks and limitations, dependency, superficial engagement, and possible erosion of deep thinking if AI is not properly mediated by teachers. Next. In this slide, I want to show how the five dimensions that we propose based on our findings. So our findings shows that AI improves technical efficiency, but does not guarantee human growth. Second one, awareness must be intentionally cultivated by teachers. The third one, students thrive when AI is paired with ethical reflection, relational presence, and guided interpretation, also by teachers. And the last one, human formation requires more than algorithms. It requires guidance, mentoring, and meaning. Next. And to conclude, I will say that the age of AI does not eliminate the need for teachers. It amplifies it. Only teachers can remind that knowledge without wisdom is dangerous. So our educators' mission is not just to teach, but to guide, to witness, and to humanize. Thank you.
Thank you, Professor Hafnes, for the insightful presentation. Now let's hear from our next invited speaker, Professor Shi Pangseng from Changzhou College of Information Technology. You may take the stage, Professor.
Okay, I begin my speech. And my title is Applying Machine Learning to Dolphin Conservation. I'm from the Changzhou Institute of Information Technology. And next slide. And this is my brief biological. And I received a PhD degree from the Samyang University, Kaohsiung. And I'm a BS and MS in EE and MCKU. And now I work in the Changzhou College of Information Technology. And I also have the professor at Shanghai Shandong University. And okay, next. And in this year, January, I received this award from the NVIDIA DLI instructor leader. And you can see this is my photo with Jensen Huang. Okay, next slide. Okay, return to my talk. And we see the ocean cover the 70% of the Earth's surface, and they contain the 45% of explored petroleum reserves, and responsible for 80 of international trade is via the ocean. And the ocean provides 20% of human protein intake. And so ocean is very important for this earth. Next. And we want to realize the healthy of the ocean. We can merge by the marine biodiversity. Biodiversity contribute to ecological stability, and ecological stability support sustainable resource development. Yeah. Next slide. And the dolphin is an indicator of marine biodiversity. And the dolphin sit at the top of the food chain and are important indicator of ocean health. And they are also sentinel animals of disease caused by environmental pollution signal potential risk to human health. Next slide. And we see the dolphin, they has a complex behaviors. And in this study, we make AI as a useful tool for understanding dolphins. Dolphin is a very complex animal. Yeah. Next slide. And this is my papers. Oh, okay, next slide. The objective of this study, and we use the image preprocessing module to reduce the impact of oblique sunlight causing water surface reflection. And we have a pose estimate module. The deep learning model was used to identify the dolphin skeleton in the images. And we have a behavior analysis module. We developed a custom behavior analysis module named as Icot AI dolphin decoder with long short-term memory ADD LSTM. This module initially used a pose estimate model to perform a preliminary analysis of the processed dolphin key points, categorizing the dolphin behavior into 6 types based on the set thresholds. And next, the previous, okay. A double layer bidirectional LSTM recurrent neural network is used to further classify dolphin behaviors. We can achieve a behavior recognition accuracy to 94%. Next slide. And we also know that dolphin has very complex behavior. And in this study, we seek only 7 behaviors. Next slide. And the 6th behavior of dolphin in this study is the first is swimming together. It means 2 dolphins swimming together, maybe more dolphins. The B is the rest. He rests on the shield. And the C is the wormy fish. The D, he is play the toys. We can see he play with the ball. And the E is side swimming. Side swimming, he means swim. And finally is hog the swimming ring. He used his body to hog the swimming ring. And we want to realize the dolphin's behavior. The traditional method, we attach sensors to the dolphin's body. But we think no dolphin's like being tied with sensors. So this is not a realistic method. Next slide. Okay, this is our system overview. And the first, we get the dolphin image. And next, we have an image pre-processing stage. And the next, here is the pose estimation stage. And finally, we have a behavior analysis stage. And the last is the behavior statistics stage. Okay, next slide. And this is our image collection field. And we can see in this pool, in the ocean park, and we have different cameras to cover this region. Next. And the first image preprocessing, we use the clash process. He adjusts the contrast and the brightness. And next we use the kernel convolution to show sharpness to the image. And this image preprocessing in this study, this help to enhance the recognition accuracy for subsequent pose estimation, resulting in a 3% improvement. Next slide. And this is a clash. He is a contrast limit adaptive histogram equalization method. Next slide. And we use the convolution. We use different kernels to do the edge detection and for image sharpening. Next slide. And after the preprocessing, and we design a pose estimation model. We use a deep cut. Deep cut is an open source tool that uses deep learning techniques to analyze and understand animal movement and the position in the video data. And it specifies designed for pose estimation in animal behavior study. In this study, we use a deep cut to analyze the dolphin skeleton. And to label the dolphin skeleton, we extract one image per second from the filmed video and categorize the dolphin into 11 key points. And the direct transfer learning-based approach enables us to accurately identify their key points without requiring intensive training data. Around 1,200 dolphin skeleton images were labeled, and we trained them, utilize the pre-trained ResNet 50 network. We evaluate the accuracy of the skeleton recognition using RMSE. Next slide. And this is the overview of the deep cut. And we can see on the left and left down, and we can see we pick the 11 skeleton points on the dolphins, including his rostrum, his tail, his fin, and his body and the belly. Next slide. And this architecture of diagram of our ResNet 50. Next. And this is our deep cut network architectures. And the output this network includes the score map and the PAF map and the key point future map. Next slide. And the PAF is part affinity field. And this is the output of the deep cut modules. Next slide. And next, we do the dolphin behavior classification tree. And this classification, we use the four measurements. The first, EDR and the EDT. The EDR is the rostrum distance. The moving rostrum distance is noise moving. The noise moving, yeah. Equilibrium distance. And the EDT is the toy. The dolphin toy is moving, this toy. And the next is ED1. ED1 is between the dog's rostrum and the ball. And the equilibrium distance between his fin to the swimming ring. Okay. And we use the EDR to EDT to decide which behavior the dolphin swimming. And use ED1 and the ED2. We measure the dolphin's distance to the toy, his toy. Yeah. Okay. After we use the decision tree, we can get a preliminary category about the dolphin's behavior. And the next, we use an Icot AI dolphin decoder, which means ADD, to improve the accuracy. Yeah. This is our ADD. Okay. And next slide. And this is our experiments. And we get 20 hours of dolphin footage together at the Far Glory Ocean Park to create our data sets. And we annotated a total 1,200 images, identify both the dolphin skeleton and the environmental feature with them. The data set was split into two parts, a training set and a test set. And our annotation for dolphin skeleton include 11 key points. And next slide. And this is our experiment about the deep cut. And the left is the 11 key points. And we can see the confidence is very high. Is the lowest is almost 96 percentage. Yeah, and this is our result. Is we only use the ADD. We don't use ADD. When we can see the ADD, the left is the ROC, about the 6 different behavior. They have 6 lines, the 6 behavior, and we can see we must move the ADD. Yeah. Next slide. This is the ADD plus the LSTM. We can see the result is improved. Next slide. And the result of ADD plus bidirectional LSTM, and we in this experiment we get the accuracy 94.3 percentage, and the recall is 92.9, and the precision of 93.6, and the F1 score is 93.2 percentage. Okay, and we also the experimental ADD plus SVM and the ADD plus GRU, and we can find the ADD plus by LSTM, we get the better results in the 5 experiments. Okay, next slide. And we compare our research, we have compared our research result to the others' results. The other results maybe he have, and we can see include the accuracy, recall, precision, F1 macro. We are over the other researches. Next slide. And finally, is the population study. The baseline is only ADD. The accuracy is about the 82 percentages. And we use the preprocessing to remove some disturbance from the sunlight, and we can get about 3 percentage accuracy improvement. And we plus the double layer. By LSTM, we can get accuracy about 94.3. Then finally. And this is our contribution and our limitation. And this study proposed a reliable tool for observing and classifying dolphin behaviors. And it significantly saved the time for the dolphin researchers. And in this study, we want to design a tool for the dolphin researchers. And we must claim all results in this study are based on the image data from the dolphin under human care. And the future potential, we want to apply the system to observing the wild dolphin behaviors, because the dolphin is a very complex animal. Next slide. Acknowledgement. And this research gracefully acknowledgement the full support of Far Glory Ocean Park in Hualien, Taiwan. Next slide. Thank you for your attention. Thank you. Thank you.
Thank you, Professor Shipang from Kangchang Zoo College of Information Technology. For participants in here or joining us from Zoom, if you have any questions regarding the presentation from Professor Habnes or Professor Shipang Seng, you may raise your hand. Maybe anyone in Zoom? If there is none, once again, thank you, Professor
thank you.
Shipangseng and Professor Hafnes Toba for the presentation. We will now like to invite both of you to the stage to receive the certificate, which delivered by Dr. Meiti, SAMSE, AKCA, Head of Institution of Research and Community Service. Thank you so much, Professor Shipangseng. Next, Professor Hafnes Toba. We are arriving at our lunchtime, which will be available at Paulus Room on the 4th floor of this building, so you may have to take the elevator. Our next session will be on 1 p.m., so please make sure the participants can come back and on time. Feel free to ask the staff if you have any question or needs of assistance. Thank you. Before we take the lunch break, we might want to have another photo session for participants who are sitting on this side and on the right side. Please joining the middle section. We'll do a quick photo session. What p.m.? 1 p.m. Oh, 1:30. Yeah, 1:30. Please look forward to the stage for the photo session. Please fill the empty seats first, the middle. Nggak apa-apa. Iya.
Bapak, Ibu semua, kita akan sesi foto dulu sebentar. Kita akan boleh agak sedikit mepet saja. Itu teman-teman yang di pinggirnya boleh agak ke tengah saja. Ya. Silakan teman-teman isi dulu ya, jangan di ujung-ujung. Boleh isi yang tengah. Ya. Oke, mulai agak ke tengah ya teman-teman, kita isi biar kelihatan, ya penuh juga teman-teman. Ya. Silakan itu yang di pinggir boleh agak ke tengah dulu ya. Iya. Oke. Baik. Oke.
Okay, looking good. Smile, everybody. 1, 2, 3. Yay! 1, 2, 3. Oh, orange. Okay. Okay. 1, 2, 3. Way. Orange. Let's do one video. We do the same thing. In 3, you say orange. ICOT orange. Okay. ICOT orange. Okay. Okay, you guys ready? 1, 2, 3. ICOT orange. Woo! Okay, everybody, we can do the lunch break first. We can go back at 1:30 p.m. Thank you. Oh, everybody can stay seated first. We have Professor Toba here for the certificate, which will be delivered by Dr. Meiti MSI AKCA. Thank you, Professor Toba. Okay, now this time for real, we have the lunch break time session. Please come back at 1:30 p.m. and be on time. Thank you so much.
Wah, capek-capek jangan lama-lama banget ya. Sudah tuh. Sudah duluan sok, biar gantian. Sok makan dulu sok. Makan, makan. maminya. Iya, udah nggak semua orang ngerti dengan peka. Apa benda apa coba dari mana gua bingung. Gua mencoba untuk memahaminya. Sok ngomong dulu sok. Lumayan. 40 menit coba dong. Nah.
Ladies and gentlemen, we hope you enjoyed the lunch break. Please return to your seats as we will continue with the next program. Now we have our next keynote speaker, Professor Yan Chun Chang from Zhejiang Normal University. We welcome you to begin, Professor Yan Chun.
Good afternoon, ladies and gentlemen, distinguished guests. So I just start. Okay. So pleased to join the conference again. Icot 2025. It's the 13th event. I think I have participated over at least 10 times. Yeah, Professor Wang may remember the number. Yeah, I'm the fan of this conference. In the morning, we have several speakers, Professor Wang, Professor Li, talk about robots, and also Professor Zheng talked about AI application in dolphin monitoring. So my talk is related to AI and application in health. Next, please. Okay. Little bit of introduction about myself. Currently, I'm at Zhejiang Normal University. And this talk, myself is a computer scientist. Yeah, my PhD degree in computer science, bachelor, master in computer science. But somehow my recent work for cross-discipline, use data mining, data analysis in medicine, in medicine area. Yeah, I'm not really doctor. Yeah, I'm not a doctor. But somehow I got a title, an honor title last year from Royal Society of Medicine. Yeah, that's to me it's really an honor. Yeah, but I'm not a really doctor, so don't ask me to give any prescription. Yeah. Of course, I have some other titles. I'm an emeritus professor at Victoria University. Have been in Australia for over 30 years. And currently I'm editing two journals. One is World Wide Web Journal. Yeah, that's over 20 years now. That's very well established. Another one is Health Information Science and System. Okay. Next, please. Next slide. Yeah, this next. This is my journal, the Health Information Science and Systems. Last year it's 4.7 impact factor, but this year somehow dropped to 3.4. But still, even the impact dropped, but this ranking has been increased to level 2 in Chinese academic science. So next one. Next slide. Yeah, this one is Triple W journal. Yeah, that's a well-established journal. Okay, next. Okay, let's talk about the health. Yeah, because I have been giving talk in the hospital medical conference many times. Some professor introduced me as a Dr. Zhang, yeah, the medical doctor. Actually, I'm not a medical doctor, but people often ask questions related to medicine. Yeah, so often get a phone call in the later midnight. They say, "Oh, Dr. Zhang." I say, "I'm not a doctor, but a professor." They say, "I have a problem. I feel the difficulty in breathe, blah blah." I said, "I'm not a doctor, but I will pass the information to my friend. I have a lot of friends who are doctors, then get some advice." And people also ask, "Since you are a doctor, you are working in this discipline, then do you have any secret for live longer? How to live longer?" Yeah? But for this kind of question, I can't answer either. But somehow we can discuss. Yeah? But the health is really a complex, very complex issue. For example, we may talk about genetic issues, inheritance, and the environment, society environmental, environmental factors, and health care. All this added together is 40%. But what is left is lifestyle. This takes 50%. So in this sense, your health depends on, to a large extent, depends on the lifestyle. Okay, I use this one. Yeah, depends on the lifestyle. Okay, it works. Okay, good. Okay, when we talk about living style, basically talking about your mentality. Yeah, you're happy, deprived, and your diet. So what you eat, and exercise, even rest, sleep. Then others, environment, other genetics are mentioned each part. Yeah. Before that, maybe I should say something. Yeah. For the maybe we'll talk about that later. Yeah, talk about that later. Today I will just start with the introduction about big data, medical big data. Then next about the medical signal processing, EEG. That's brain signal, and then ECG. Yeah. Then summary. Okay. When we talk medical data, yeah, medical data processing, we often say, okay, what is medical data? Medical data, we often refer to the clinical data. Yeah, you see, for in hospital, we have health record, yeah, person health record, and some testing result. Those are really called clinical data, and also some health data. Your living style, your habit of resting, eating, exercise, etc. This is related to health. All this together we say medical and health record. Then, in computer science, we treat this data as text data, time series, three-dimension data, network graph, image, data stream, etc. So this kind of data. Then we have data. Then when we're talking about smart medicine, we often talk about AI plus medicine. Then often refer to following items, for example. Data, algorithm, computing power. Power, well, no, okay, now we have GPU. Then algorithm more refer to AI algorithm now. Yeah? Then data, medical data. When we talk AI in medicine, we try to make AI, try to providing the AI capability for some kind of sensing, learning, understanding, just like a human in medical field. Few area like has been very successful is vision, yeah, and also, let's see, okay. Here. Vision, language, sound, even the image processing. So we have seen the success in those areas. So now how to make a robot, like Professor mentioned, to have robot to have this kind of capability. That's a major work in recent time. Now what I have done basically in few areas, medical imaging and disease assessment, prediction, etc. I have been working in these areas. Currently, I have led a several research group in China, like in Fudan University, Chinese University of Science. And today I will focus on two areas. One is EEG analysis, and another is ECG analysis, etc. About this one, about EEG analysis, Professor mentioned the brain, yeah? Our brain has over 2 million neurons. Have, for example, here have over 10 million cells, neurons. When we are reading, those cells will be stimulated. When they stimulate, they will generate microelectricity. Also are connected through some connection. Then that's your brain. Yeah? This brain will generate some electricity. If we have some machine, like machine put in your head, we can test. Have some electricity. What pattern of this electricity? Your electricity may like this. Okay. Your brain may like this. Electricity, some wave like this. From this wave, we can say, you are falling asleep, or you are awake, or you are thinking something else. Yeah, if I have your electricity data, EEG data, then I could see what you are thinking. Not exactly, but I know whether you are falling asleep or not. So there are quite a few patterns, like delta, theta, alpha, beta, gamma, mu, this kind of pattern. They have what a feature like this. Okay, this one, delta wave. So some of you, if you are falling asleep, your EEG signal just called a slow wave. Yeah, slow wave. This deep sleep between 0 and 4 hertz. That's slow sleep. This one fit 4 to 7, and this one is the alpha wave, the beta, etc. That's gamma. You say gamma wave is different from others. If someone is experiencing seizure, yeah, epileptic case, then that will be like this one. Yeah. So your brain signal, if we know your brain signal to a large extent, we know what your activity, brain activity. Yeah. For this, for example, this one, when you are excited, relaxed, drowsy, asleep, deep sleep. The deeper side, slow wave, deep sleep, and coma. If for someone follow in coma, the EEG signal may like this. So through EEG signal, what we can do? Through EEG signal, what we can do is, okay, to detect a neurological disorder, and a brain-computer disorder, for example, brain-computer interface, to have your life quality, to check, detect the disease, autism, dementia, brain tumor, sleep disorder, etc. With the EEG signal, we can help to diagnose some disease. Okay. Now let's come to the first part about sleep. Especially after lunch, I'm sure after lunch, everyone is falling asleep. Yeah, and falling asleep. When you're falling asleep, the EEG data may look like this, slow wave, as I mentioned. We know, if I ask a question, often in the morning when I ask a question, how is your sleep? Many people will tell me, terrible, I sleep not very well. I sleep only 4 hours, 5 hours. Yeah. We say sleep is important. Everyone, 1/3 of our total life we are in sleep. Yeah, normally 8 hours of sleep. Yeah. And sleep, we often say sleep. Whenever people ask how you sleep, you only say 4 hours, 5 hours. Actually, more professionally, we say your sleep structure. What's your deep sleep? What is your REG, repeat eye movement? There are different patterns. Normally, this can show you the different sleep pattern. Okay, we say function. Why do we need sleep? There's a function, sleep. When you feel tired, sleep can help you eliminate fatigue. physically restore your energy. And this we know. Yeah, we feel tired. Go home, have some sleep. But if you are not the physical tired, but mentally tired, especially in the university, the due date come, will need to prepare exam, prepare submission, then couldn't sleep well. Outside, we need to sleep. Sleep can help you restore your energy. Because, for example, during the sleep, that's enough sleep energetic, quick thinking, and efficient. From here, I just mentioned, during the sleep, the heart rate, blood pressure all drop. Yeah, then metabolic rate is all reduced, so physical strength can be restored. And in the mental part, have enough sleep, are energetic and quick thinking, etc. And also there are some other news and other functions. Okay, let's continue to talk about sleep. Sleep is one stage called rapid eye movement. During the sleep, this one period of time, eye keep moving, moving fast. In this case, we call rapid eye movement. Actually, this was discovered in 1953. One student, PhD student from Russia, and his professor, his supervisor professor from Germany, the student found, during the sleep, the people eye keep moving. Yeah, this is rapid eye movement. He told this to his supervisor. His supervisor said, this is quite interesting. We need to do some further experiment. Then they put one EEG machine to her daughter and to measure this EEG data. Then the whole night printed around 1.8 miles. Then from this, they say, indeed, during the sleep, there's quite some special pattern, eye movement, rapid eye movement. Especially when you look at some baby, you see the baby during the sleep, babies keep smiling and sometimes eye moves. Yes, that's a part of eye movement. Since they discover this kind of movement, then they divide sleep into few stages, just like this. For example, there's a weak stage, then N1 stage, N2 stage, N3, this deeper sleep, rapid eye movement in this stage. What is a weak stage? Before you want to go to sleep, but now after shower, no one go to sleep. Then you have to see to watch this mobile phone, the some news, some video, short news, you see that. Afterwards, then you fall asleep, go to sleep. Initially awake, then on one stage, you close the eye, begin to sleep. This is very N1 sleep. This is very light sleep. This one is getting a little bit deeper, but there are special patterns. Then go to deeper sleep. This is slow pattern. Then eye movement, something like this. For example, in the beginning W stage, wake up stage, something like this. This low amplitude, this alpha pattern, alpha pattern. Then next, this N1 stage, alpha wave begin to reduce. Then that's normally between 2 to 7. Then next, this will be the N2 stage. There appear some special pattern, keep complex, sleeper spindle. Then this one, we say this deeper sleep. This is slow wave. This is between 0, for example, here is 0 to 2 hertz. And then another one is like eye movement, quick eye movement. You see show that this mixed. The frequency is quite frequent, but the peak is lower. So this is rapid eye movement. But so you are sleep, for example, you sleep only for 5 hours, but some time period is deeper sleep, some period is rapid eye movement. But what we say is, okay, see, before I say that, we say you sleep you have 5 stages, but actually, when we fall asleep, there are several cycles, not just fall asleep, wake up in the morning. Normally you wake up several times. So whole night sleep just like this. Okay? This you follow up sleep, then wake up, then fall asleep again, then wake up, fall asleep again. So it's very normal. 90 minutes to 2 hours is one circle. But some of you may, I just sleep a whole night. Actually wake up, but you don't remember. You wake up, you fall asleep again, you didn't remember. But when you sleep up, you want to do something, you want to watch your mobile phone, do something, certainly you remember you didn't sleep well. So wake up, continue to sleep, you don't remember. Then what we do with this one? Actually, we have with this overnight sleep data, we can calculate to see what's the time period for the N1, N2, and eye movement. What we do, for example, we cut this, you think about how EEG signal like a wave, then we cut into pieces, then to see this point, how they connected. If one can see each other, we connect, then like this, then we build a graph. Yeah, build graph. From this, we can calculate whole night sleep, the frequency. Yeah? If in this case, we say, okay, we calculate in the whole night, light sleep like this, or this light sleep, this deep sleep, and eye movement, etc. So in this case, we say, okay, there's some standard part. We say, okay, for this example, we go back. There's some normal pattern. There's a normal pattern. But from here, we say, if you have some sleep problem, then normally in the hospital, they will have one night check, see your EEG signal, then they will say, okay, during your sleep, you have how much sleep in N1 stage, deep sleep of repeated eye movement. Account to this, they continue to what's the problem. So this is the issue. So next time when they say, what's your sleep? I say, only 4 or 5 minutes. That's not enough. We'll say 4 or 5 minutes, what is deep sleep? Actually, there are many people use the iWatch or some ring to collect your signal, your heart signal, what your sleep, your heart rate, etc. Like this. So this sleep part is important. Before this, I just tell a story. When say sleep why important, when say the former American former President Donald Reagan, and he sleep for 5 hours a day, 5 hours per day, and also Thatcher, UK's Prime Minister Thatcher, Lady Thatcher, also for 5 hours a day. And you know what happened to them now? They all got dementia, Alzheimer, so sleep, that's just example for sleep, lack of sleep, then not good to your health. But you know, Malaysia's president, former president, Mahathir, he just stepped down recently last year. He is over 100 years old, and also his wife. Both of them are doctors, both of them are medical doctors. Certainly they know what is how to, when in the beginning we talk about health style, but certainly they know the health issues. If you ask them how to live longer, they will tell you the inheritance, environment, and also medical care, plus this living style. Okay, that's the story. Let's come on. Then we say sleep pattern is one thing. Then if you know the sleep, okay, we have less time for the N1, N3, N4, and rapid eye movement, etc. How this related to different disease? We only say sleeper is not well. How is the disease? One particular disease called narcolepsy. Narcolepsy is kind of a disease, especially in some older people fail sleep. Suddenly they need to sleep, and suddenly lost this muscle tone. Yeah, the catalepsy, suddenly better loss of muscle tone. Yeah, loss of muscle tone, you need to follow sleep. Another kind of not loss of muscle tone, but you need immediate sleep. So that's the things like this kind of disease occurs to 0.05%. So every 10,000 people, there may be five people. The life quality is low. So we have been working with one hospital. They gave us data. We help them do some processing. Okay, you have the sleeping data. Then we'll see, for example, processing using deeper mining, trying to do further analysis. We find out, for example, this is case. This EEG data, then we convert to cut into pieces, this image, and then we convert into the frequency data. Once we convert to frequency data, we can see the pattern. How is the N1, N2, N3, and this eye movement. Then we did some experiment. Then we find this. In this experiment, we find the red color stand for the data for those people with narcolepsy. And those blue one is normal. You find out during these two diagram, during the W stage, wake up stage, and the REM stage, the patient, narcolepsy patient, lack of this theta pattern. So from here you can see the difference. For those people who like theta pattern during the W and also rapid eye movement, then this possibly people get this narcolepsy. So after we gave this to the hospital, they say, oh, very confident to the scientific discovery. So this help them to pre-diagnosis. So that is kind of work what we have done. This has been working with two hospitals in China. One is more related to sleep, another one to mental health. Continue with mental health. One work, this also really sleep. Yeah. You know someone sleep, do you know someone sleep with a heavy snow, yeah? Just like, you can feel like of breathe, yeah? So that actually, this is kind of what we call it's obstructive sleep apnea or hypnea. So when sleep something, apnea was given as 90% drop in respiratory flow for active 10 seconds. This is called apnea, sleep apnea. Another one is dropped 30% for 10 seconds. This is low respiration. So this is kind of also the sleep problem. Yeah, actually the exact number may be not exact important. Actually, you know someone when they sleep, they make a lot of noise. Yeah, but reason to make a noise is that, for example, that's actually related, or this, I don't have this. For example, this flow channel, for example, when you are young, that part is strong. When one getting old, that upper channel is not strong anymore. Maybe laying down, then make the channel narrow. So you need more space for the breath. So in this case, you find this some kind of effort to have more breath. So this one, I come back again. This definition, come back again. For example, in this case, it's normal sleep, yeah, not normal breath. You breathe like this. And this one suddenly getting low. This one stopped for 10 seconds. So this apnea, this hypnea. So this one is stopped breath for a while, another is low breath, etc. So this kind of disease, yeah, kind of disease. Yeah. So because if you have snow, heavy snow, then didn't sleep well during the daytime, will be much tired. It may cause other problems. So one work, what we do is, okay, we collect data. One is breath data, and another is oxygen. Yeah, because when you breathe, at the end of the oxygen level is low, then we see what's the oxygen level. Then certainly the two fingernail we use deeper mining, then and there's a merge and there's then we do some classification, yeah, what is the problem? Then this work will help to diagnose the patients with, hypina and also this opina, hypina. Yeah, this is the work mainly related to this FNAO, related to FNAO problem. So there's some data, yeah, this is first one, maybe in Chinese, okay. That's related to the sleep problem. Another problem is related to the mental health. This one is related to the seizure. When you say our brain, the cell, or say 10 billion cells, each cell generates micro electricity. The electricity is small, but you think about it. If a part of your brain is synchronized to generate electricity, if one part is synchronized to generate big electricity, it synchronizes certainly the amount is big, then what happens? You will be, that's the seizure, then that's epilepsy, seizure happened, something like this. Then what you say this normal people, but this during the epilepsy, yeah, during the epilepsy, yeah, that's a seizure. So what do we do with this kind of data? For example, this is data, all the data we collect data from patients. So now we do pre-processing and get the feature traction, then classification to say with this problem not, a seizure or not. Before this, I tell a story. I remember one day, I gave a talk. I said, sorry, I'm later. Yeah, I just came back from the mental hospital. Yeah. This week, I went to mental hospital twice. Then the student asked, teacher, are you okay? I said, I'm okay, but I send my two students to the mental hospital. The people laugh at what happened. I said, because we work with the hospital, I send a student to learn the data, to understand the features, characters of the data. So, for example, only data like this, what does this stand for? Yeah, the data is not very regular, but sometimes during the data collection, during this experiment, if you think about it, for example, during the experiment, if you think something very sad, think something very happy, or if there's some movement or some signal interfere with your testing, then the data may generate some noise. So what we send our students there to understand data, first thing we need to do pre-processing to remove noise. Remove the data. After clearing this noise, then we take a feature, then etc. Then we see whether this problem or not. But for example, use a static feature. Okay, you think about the whole signal like a stream, data stream. We cut into pieces, and for each part we have find some static features, max value, minimal value, Q1, Q3, etc. The average, etc. Then we go to those kind of value. Yeah, you think about each part, this with those kind of point, this vector. Yeah, with this one we convert it as a point. Then we can use supporting vector machine to classify. This is a patient with this normal people. Others patient with epilepsy. Yeah, with epilepsy. So this is a traditional one. Another work is one for my PhD student. Convert this data into a diagram, into a graph. Once convert into graph, we check what's the problem with this node and the age, this kind of thing. For example, this is how to convert the data into this. For example, this is EEG data. We cut in pieces. Then we say, okay, connect. Just like this. If they connect, then we go to a graph. Then depends on this ratio. Then we have this weighting. Yeah, weighting. Then we get this kind of graph. Yeah, we go to this graph, this weighting, this graph. This normal graph, the graph of our normal people. This graph of our elliptic patient. Yeah, elliptic patient. So you see the difference. Yeah, but actually using the computer and the system, we can find the difference. So this is one way. And also, there's some other work to continue with this. Then we also have quite two works, for example, for the automatic detection schizophrenia. This is for the bipolar. Yeah, you have a problem, for example, that's mental health, you have a bipolar, then that's one of its work. Another one is related to the dementia, Alzheimer, yeah, but mainly in the early stage, sometimes you forgot things, yeah, when people are getting older. Why am I here? Yeah? Who am I? Yeah? That this early stage we do something help. Basically, it's through EEG signal we can help to find the pattern to do some early diagnosis. So that's one thing. And another one, that's basically related to the EEG. And another work related to ECG. That's one of my early work. Monitor the patient in the operation theater or intensive care. For example, this, especially when during the operation, what we do is, for example, during the operation, then this first one is anesthetist. Yeah, anesthetist. Yeah, anesthetist. Once during the operation, something like this. The doctor come to see me. Okay, during the operation, for example, then something may happen. Everything may happen. If something happens, we need to stop the operation. Then need to do emergent risk. Then they say, oh, how about we give you our data to you, you do analysis, then you help us know what may happen in the next few seconds. Then this will work. What we have done is, basically this stream data processing. Then your ECG data and other data, just like this data. What we have done is, okay, we just find the pattern, find this stream data, find what pattern to do early warning. So then our work has been reported, say, few seconds can save patient's life. And this surgery made it safer when program predicts patient's vital signs. And you may not, some may not this Chinese character, yeah, they translated into this here. So that's work actually what we have done is, you see, before the operation, we have all the data. During the operation, doctor need to continue to put drugs, for example, to stop the pain or to wake up. And this is during the operation, they see your data. For example, this your data, this EEG data, and this pulmonary artery data, and respiratory data, all this data. Then we treat all this as data stream. Yeah? Then we look at the pattern. Okay, what's the problem with the data, the correlation with the stream, then this kind of data. What we have done is, for example, compress data. For example, this continuous data we compress to the 5 to 10,000 point. Then you see, during the process, we only need this small data set. We only need to know this change pattern rather than the whole continuous data. With this one, we can find this, for example, find this peak point and at where this increase, etc. Then eventually we cluster all the different points to see what's the problem. For example, we can check the problem with ECG1, ECG2, ECG4, etc. Then we can give them some diagnosis. For example, in this one, we find this PAP, abnormal score is 2.2, and this CVP, 2.0.2, we gave this to doctor. What's the problem? Okay, so this common wave in CVP and retrograde wave in pulmonary. We have to give this to the doctor. They say, stop operation. The patient is in coma. Yeah, we need to do risk. Yeah, those kinds. So that's just example what has done in ECG, in operating theater, intensive care, etc. So this is some work we have done. For example, through this we can see what happened. And some other work related to medical image. Due to time limit, I don't want to talk more about medical image. Just I try to finish. This is pattern recognition, medical image, and some work with cancer and this recent work. Now I got to stop here. What we want to do is really help a doctor to, then what we do is, for example, involve from computer science, data acquisition, information, correlation analysis to accurate prediction, early warning, etc., and it was software applied to the hospital. Then other things related to the management, health care, etc. But recently, if I have time, I want to talk more about recent large language model. We use large language model mainly to answer questions, to help the summarization, etc. But still, there are quite a few issues. But after all, we need a more close collaboration with expert scholars in the field. More collaborations. For example, you have technologies here, but eventually in health, not just only treatment. We say comfort. Person wants the driving for this Icot, with own technology. One particular area is care. Is care. Care itself, and also how to comfort the patient. Certainly, this many models like larger language model, ChatGPT, DeepSeek, etc. But how this help us to increase the efficiency or accuracy of medical treatment? This is a lot of work need to be done. For the time being, I think our time is up here. I stop here. Okay. Thank you very much. Okay.
Give a round of applause for Professor Yan Chun Chang from Zhejiang Normal University.
Stop here? Okay.
Yeah. Before we continue, we would like to share an important announcement regarding our invited speaker, Professor Insinyur Paulus Insap Santosa, MSc PhD IPU, who are already arrived in Bandung and was fully prepared to join us today. However, due to unexpected and serious health condition, he is unable to attend this event this time. We sincerely wish him the best recovery as swift as possible. We deeply apologize for any inconvenience this may cause, and we appreciate your understanding. With that, we want to jump to the question and answer session with Professor Yan Chun Chang. If any of you who is here or from Zoom online meeting, if you have any question, you may want to raise your hand. Yes. Please share your name and the question. Yes, please stand up.
Thank you. Good afternoon, sir. My name is Hans, and I'm from Department of Civil Engineering. So I want to ask. I see that you haven't mentioned the effects of dreaming. Does it affect to either ECG or our EEG signal? And also, does it affect also the data that's going to be processed by the AI itself?
You talk about the data process, yeah?
Yes.
Actually, that's one, I just made stories and talk about the data processing. For example, we have EEG data like that, but if hospital just gives data to us, we really don't understand what that EEG for, because suddenly there's a drop. For example, when you close the eye, open, data like that. During the test, if you think of something very sad, then it will affect your mental. then the activity will be different. So in this case, all the data processing, talking about data quality, then we need some collaboration with the expert. We need to understand this domain, understand these features. For example, you have this data suddenly drop out and up. We need to have a continuous, smooth data. Then how do we make it smooth? If we understand the feature of this data, now what's the reason, then we can make the data better for the data mining or AI. Because AI, they need to have some kind of data, labeled data, or some kind of clean data. But initially, the data is not that clean. So even for EEG, ECG, we also need this kind of clean data. Especially for EEG, I send the students to work with the doctor to understand data. Then after this pre-processing. Is that what your question about data quality?
How about the effects of when we have a dream? Does it really affect the EEG or ECG when we have dreaming?
What it means? Effect?
Like when we have dream, when we are dreaming, does it affect the EEG or ECG signal also?
Okay.
Because it's like we are in a conscious mode.
Okay, your question how? Your question about dreaming. This is a really good topic. Why we are dreaming? Sometimes when you think something in the daytime, when you think something, but in the night sometimes you may continue to think about this, then somehow connected, then you're dreaming. Dreaming for the Eastern, Western, they have a different explanation. For example, maybe I can say, yeah. For example, if I dreamed one from my ancient, my grandpa who passed away, if I thought, suddenly why I dreamed about my grandpa or someone. Then you think about, it reminded me I do something, I go to this tomb and to have some, to pray and something. And after that, you feel the comfort, This mainly is kind of psychological thing, have a dream. So sometimes you suddenly dream something, then maybe you have been think about something or something come together. A dream is kind of doing the eye movement, repeat eye movement. For example, during the daytime, we learned, studied, even listened to the talk, but during the night, during the eye movement, we begin to process and clean up to store the data and this kind of thing, mainly to processing. And also during the deep sleep, we clean the brain because we have, in brain you have some liquid, Some liquid, yes. When often joke, don't laying down your head in liquid something, just make a joke. But when people get old, the more liquid. When you sleep, deeper sleep, you have more space, then liquid go out to help you clean your brain. So there are many other issues. For the dream, there's a book about how to explain the dream, but I can't explain that talk, but somehow dream is related to many things. If someone they say, in the Western they say, dream is a kind of a communication from our world to other world. Why you dream of your ancestor, then you communicate. But somehow, this is our kind of psychological explanation, I just, sometimes I make a joke, when I retired, I will just do some work to help to like a dream. I had a dream, come to me, I will help you say, this dream stand for what, and then you do. Okay, any other questions? We have more time today, we have another speaker is not here. Yes? Yes.
Please state your name and the question, please.
My name is Rico. I'm from electrical department. I want to ask about personalized medicine. Because personalized medicine.
Okay.
Because AI has grown very fast and also move into healthcare. So what do you think about the spatial issue, or what kind of technology that AI may solve or help to the problem of personalized medicine? Thank you.
Yeah, that's an interesting question. Technologically, we have many mature techniques. For example, you have give a medical image. Yeah? We can, through the medical image, clarify, this is brain cancer, that's what brain cancer. But at that stage, when you say, well, accurate. But many techniques are not really incorporated in the workflow of a hospital. Because in the hospital, they follow the procedure from the initial registration, then go process. But suddenly you say, I have a medical image to give to you, help decide. It's whole process, not just to say whether you are cancer or not. Whole process is diagnosis and treatment. It's a comfort, like this. Yeah, technologically, we have technology there, but when they are incorporated in the medical domain, there's still issues, because when you say personalized, what do you mean personalized? Same treatment may not work for everyone, because I have my personal difference, my inheritance, my history, and also my reaction to what kind of medicine. So one medicine may work for 7 others, 8 others, but for 2 may not work. There's 2. Who will take this kind of responsibility? For general, for example, for large language model, LLMs, deepfakes, is for general language understanding. You say, this understanding is much better than ordinary people. Yeah, accuracy is from 6% to 7%, 60 to 70% accuracy. It sounds very interesting. But come to our medical domain, in the hospital, even we say accuracy 90%. When we say 90%, are you sure? If you want the AI to help you to diagnose, to treatment, 90%, you are in this 90% or you are another 10%. So this is who will take responsibility, and also this ethical issues. So this need the collaboration with domain expert and computer science scientists, and also some kind of government policy. What's the responsibility? Who takes the responsibility? For example, you ask the robot, say you do this, then who will take the responsibility? You do something wrong, you come say, who's our inventor? Professor Wang, this is Professor Wang's robot. Then Professor Wang said, we just provide the technique. You have to incorporate into your domain. For this things. That's also mentioned why we need a collaboration with domain expert, because we have general knowledge, but we don't know so many differences. Okay, let's answer your question. One more. Good.
As we know that maybe medical image is one tool to assess one's health, but recently I heard about in the level of cell, in the DNA of every person, we may specifically describe about someone's health. So what do you think? How can AI use this information also to help us to get a personalized medicine? Thank you.
Personalized medicine or process medicine, there were many issues. But basically, there are genetic features.
I mean, like this, Professor. every person has a specific sequence of DNA.
Yeah.
Because this amino acid for every person, the chain or the sequence is different. I think the difference between every person for his or her DNA may affect the personalized medicine. So what do you think?
Yeah.
How AI may help us?
Yeah, that's a scientific question. For DNA, for your DNA, his DNA, very similar. Maybe only different on this particular 2 parts. If a treatment film okay, then these 2 parts may not be critical. But sometimes these 2 different parts may play an important role to distinguish different treatment. So this theoretically, that's we say 99% are same. But for particular treatment for our disease, they must be different. So that's theory okay, but in reality there are a lot of issues, especially you talk about DNA and this the genetic things. There's a lot of genes, gene marks. Yeah, a lot of theoretical work. Yeah, you are right. Yeah, good. Okay. Any other question?
Any other question?
About health, you want to live longer. You want to live longer, you have a good health lifestyle, yeah? Exercise, eating well, have a good habit. And yes.
Sir, my name is Novi. May I know about your research about the EEG to detect early warning detection for epilepsy? Okay, is it how to install the EEG to the patient? Because maybe EEG is very sensitive probe, and is it any other sensor you use besides the EEG? And is it all the channel of EEG that you use to classify?
Okay. That's a good question. Yeah. In the hospital, normally they will give you some 12-part channel or even 35 channel. If you put all these channels, you can't survive too long because very painful. Yeah. So then sometimes they use 1 or 2, from the frontal, and other than use this one. Yeah. Then simply, the more accurate. There's many work say, okay, how many for particular person, how many will be better? Yeah, 1 signal or 1 channel, 2 channel, or for each area that's 1, then they have some work. Yeah, for example, different one. Yeah, for many. Some work just use 1 put here. There's some kind of indication, and there's a EEG signal, and also they have this your eye, the eye, other signals. Even in ECG, come together, but EEG is mainly more related to brain activity, but somehow some other signals. For example, you have when you go to the hospital, for example, PPG. Your brain activity, EEG, muscle movement, and other things altogether. Yeah. But in hospital, then certain more data, and actually, this normally your heartbeat, breathe are somehow related. Before the epilepsy happen, then there are a lot of other changes. Yeah. For example, commonly we use even some run, Google's run, then how you collect information, all are correlated. But somehow your data, what we have data, we can't take this as evidence in the treatment. Because hospital, when you go to hospital, they want to do their checking. They think more professional. Yeah. But people ask, I have this data given to you, why you check again? Even you have data from other hospitals, they want to their own check. They want to make sure the result is consistent. So that's a really issue. Yeah, we have this mobile device, but this device certainly help us to raise the health attention. Yeah, but somehow not incorporated in the medical diagnosis because it's not consistent yet. They are more accurate. Here is more loose, not that accurate. But to us, we have this one help us to understand ourselves. How many steps per day? What our heart rate during the working? Then if it's too high, we stop. Yeah, that's at least help us. But those are not consistent with the doctor's diagnosis yet. Yeah. But eventually, more equipment will more accuracy, even connected to the hospital doctors, such as in remote treatment monitor. It will be there. Yeah, thanks.
Okay, Professor.
Yeah. Okay. Any other question? I think I'll take the time for another professor's talk. Okay. Okay. Maybe stop here. Okay. Thank you very much. Yeah. Yeah. If you have question, you can send an email to me. You can find my name in my email. Yeah.
Okay, thank you for all the questions, and once again, thank you for Professor Zhang for answering our questions. We would like now to invite you to the stage to receive the certificate delivered by Dr. Meiti S.A. MSI AKCA. Once again, applause for Professor Yan Junjiang from Zhejiang Normal University. We would now like to have a group photo. Ladies and gentlemen, please remain seated and look forward to the stage as the photo will be taken from here. Everyone who sit on this side, please move to the middle section. Boleh dirapatkan lagi? Okay, get ready. One, two, three, cheese. Wow. Alright. Make a circle with your fingers and say orange on three. One, two, three, orange. Once more for a video. We do the same thing, okay? I see with the orange.
Okay, good afternoon, everyone. Today we will start our parallel session, and the first speaker is come from Maranatha Christian University, Professor Maya Malinda, PhD, and she will deliver about the digital transformation of SMI in Asia, a systematic literature review. And I call you. The time is yours.
Okay, thank you.
Okay, the time is only 10 minutes for presentation.
10 minutes. Okay, thank you. Okay, good afternoon, everyone. Okay, yeah, I have a story today. Let me begin with a simple observation. Across Asia, small and medium enterprise are the backbone of our economy. Yet in the last few years, many of them face the same dilemma. We know digital transformation is important, but where we do start? That question inspired this study. My name is Maya Malinda, and today I'm sharing a journey through the digital landscape of Asian SMEs drawn from a systematic review of research across the region. Next slide. Okay, setting the stage. As I explored more than 5 years of studies from 2020 to 2025, one thing's become clear. The digital transformation is not just a trend, it's become a survival strategy. But the story isn't the same everywhere. Some countries race forward with many struggle. And then others struggle with basic infrastructure, and this contrast, it was make the Asian SME landscape so fascinating and so important to understand. Next slide. So I start with 4 guiding questions, almost like 4 doors leading into the same house, that push SMEs to adopt digital tools. what holds them back, what happened when they finally adopt, and where the research still silent. These 4 questions become the compass of the entire review. So we have 4 research questions. And how the journey was conducted. To answer them, I conduct a systematic literature review using the Prisma method. I think of it as cleaning a messy bookshelf, removing duplicates, filtering irrelevant topics, and organizing everything into a clear structure. I research through Scopus and then Web of Science and other reputable database. And after careful screening, the most relevant studies emerge to tell the story. Chapter 1. Next. Okay, this is the methodology, okay, from research. And then next. And then I start with the identification, okay, from screening around 1,423. And then I remove the duplicates and screening. And finally, studies include in final synthesis around 55 paper. Next. Okay. So, the story, what drives SMEs to the digital. The first chapter in this story about momentum. The force that push SMEs forward. Government in the Asia have been surprisingly active. Digital India, Malaysia Digital Blueprint, and China ecosystem led by Alibaba and Tencent. But it's not just a policy. Consumers are changing. Fintech is booming. Mobile internet is everywhere. The e-commerce platforms are becoming the new market square. Together, these forces become a strong wind at back of SMEs. Next. Next. And the barrier of the digital transformation, every journey has obstacles. Some SMEs want to go digital but lack of skill. Others hesitate because technology feels expensive, too risky. The rural areas, even electricity and internet access cannot be taken for granted. And many family-owned businesses resist change because we have always done it this way. This friction point slow down the transformation, even when the desire is there. Okay, next. The outcomes. When SMEs do manage to adopt digital tools, the impact can be remarkable. They reach customers they never imagined. They cut costs, streamline operation, and become more efficient. Some innovate entirely new products. During COVID-19, digital-ready SMEs were far more resilient. It almost like digitalization doesn't just change the business, it changed the mindset. Next. So we also highlight heterogeneity across Asian economy. In Asia, it's not one homogeneous region. China leads in the digital infrastructure but still has rural gaps. India is booming in fintech but remains cautious about cyber security. Southeast Asia, including Indonesia, Vietnam, is rapidly growing thanks to e-commerce. Japan, Korea are focused on advanced Industry 4.0 tools like IoT and AI. Meanwhile, countries like Bangladesh or Sri Lanka still lack structured support. The diversity is rich and it shapes its SME reality. Next slide. So, in discussion, to understand all these differences, I look at 3 theoretical lenses. The first is technology acceptance model and also unified theory of acceptance and use of technology. Do the SMEs perceive digital tools as useful and easy to use? And then for the technology organization environment, do the technology organization and environment interact? And also resource-based view. Do SME have the internal capabilities to adapt? When combined, this theory gives us a full 30-60 degree views. Okay, so how to the impractical implication next? One, so we can learn from all this, policymaker need to build ecosystem, not just a program. SME owners must invest in skills, cybersecurity, and leadership. Investor and development partners should look forward emerging markets and underserved sector. Digital transformation is only meaningful when it becomes inclusive, sorry. And then next, okay, the theoretical contribution. So here is where the story brings us. Asia is moving fast, but evenly, digital tools have empowered many SMEs. Yet the barriers continue to widen the gaps between the digital haves and the have-nots. Understand this dynamic is the first step forward to more equitable digital future. Future research. Next slide. Next slide. Okay. The end of this story doesn't end here. There are chapters still unwritten. Long studies, and then cross-country comparison, new sector, and then sustainability and impact of industry for zero technologies. And this question opened door for future researchers, including many of us here today. So, next. Next. Thank you for joining me on this journey through the digital transformation of Asian SMEs. I look forward for your question and for discussion ahead. Thank you very much. Thank you.
Okay. Any questions? No? If you don't have the question, it's okay. So give applause for Professor Maya. Thank you. And the second speaker is Pak Jimmy. Okay, Pak Jimmy Lukito. Where's your PPT? Wait. Okay, I will. You already prepared. Okay. The title is about the design and evaluation of Care Linker, a mobile health application for elderly care in Indonesia. The time is yours.
Good afternoon, everyone. I'm Karenina Wong, and I'm accompanied by Bonifacius Baidon Hansel from Computer Engineering, Maranatha Christian University. And we will be presenting our study of design and evaluation of CareLinker, a mobile health application for elderly care in Indonesia. This study is supported by visual communication design from the Faculty of Humanities and Creative Industry. In this presentation, we will go over the introduction, methodology, results, and conclusion, along with the future works and acknowledgement. This is the key features on why do we create this application. The elderly population reached 11.75% in 2023, and is projected to surpass 65 million by 2045 by BPS. And most of them in Indonesia prefer to live with their families rather than in nursing homes, with only 5.5% living alone. 44% of the elderly suffer from comorbidities, yet most rely on family care rather than nursing homes. This information is from the Ministry of Social Affairs in Indonesia. This cultural preference often leads to caregiver burden, stress, and inconsistent health monitoring due to modern lifestyle constraints. There is also a lack of effective communication between family members and medical staff. This is from the R. Suryani and F. Wijaya study. And thus we would want to create an application that can help with this struggle. Next. This is the methodology we use to create this application. We use the Flutter for the front end and the Supabase as the database backend. Next. And this is the API architecture and real-time synchronization flow using the Flutter as the front end and the Supabase using the Postgres SQL as the database. And then we create an Android mobile application. And the flowchart presented in the picture shows us the steps we take to create this application, starting from creating the database, the tables in the database, in the Supabase, and then creating the Flutter front end, connecting the Flutter front end with the back end or the Supabase, and then we implement the authentication module, develop the main features and pages like home pages, elder management, health records, etc. And we optimize the performance. After that, we test the application or the testing phase. In the testing phase, we will try to find any bugs or error in the application. If there's a bug, we will optimize the performance again. And if not, we will consider the application done. Next. This is the list of the tables we use in the database. There's users, elders, user-elder relations, medication schedule, health records, medical files, financial records, shared notes, event calendar, and vital signs used to store the data in the application. Next. And this is the user interaction flow of the CareLinker application. So at first, the user will log in, and it will store the data of the user in the users table in the database, and then select elder. After that, the user will be addressed to the home page that stores the notification, schedule and routine, medical data, finance, shared notes, settings and accounts, and emergency button pages. In the medical data, there's also medical file pages. After that, the user will log out or close the application. Next. This is the testing methodology we use for this application. There's black box testing and the usability testing. The black box testing validate all functional requirements. For example, the reminder synchronization operate correctly without errors. And the usability testing evaluated using the system usability scale or the SUS with 15 participants. all caregivers and young adults to measure satisfaction and ease of use. After this will be the results and will be presented by Bonifacius.
Okay, now I will move to result section. I will explain three results: system testing result, user evaluation and comparison with existing application. Next. This slide shows the result of the black box testing result for the main feature of our application. Unfortunately, the table not shows. We tested 5 core functions. They are user login and registration, elderly data, medication reminder, health record entry, and shared note. For the testing result, most features work as expected and were marked as pass. There was only one issue, the table not showed. In medical reminder features, they are delayed for 1 minute. Overall, the system functions were successfully validated based on functional testing. Next. This slide presents the SUS score from our usability evaluation. So we involve 15 participants, including caregiver and also young adults. The individual scores range from 77.5 to 87.5, which indicates constantly positive user experience. Next. This slides compares between CareLinker and existing mHealth applications. In terms of functionality, CareLinker provides more complete features such as family communication, financial tracking, and also multi-user roles. Unlike the several existing apps, our app also supports local data backup and accessibility designed for elderly users. Next. Conclusion. Next. For black box testing, there are three key outcomes: core functionality, medical reminders, and also shared notes. For the core functionality, features such as user login and registration, elderly data, and health record entry, confirming that data is correctly stored and retrieved from the supervised backend. For the medication reminder, initial tests revealed a minor latency, but still successfully to receive the notification. And shared notes, the system successfully validated the multiple authorized users, family and caregivers, could read and write notes simultaneously. Next. SUS score. There are two conclusions, quantitative and qualitative result, and also user feedback. Overall, the application achieved an average SUS score of 82.4. Interpretation, according to the Bangor et al. Scale, this score categorized CareLinker usability as excellent because the score above 80. For the user feedback, participants highlight the fast system response and simple navigation as key advantages. And for the improvement, maybe we can add a larger icon and also the button size for elderly user with significant vision decline. Next. For the future works, there are 5 future works. Accessibility for like adding support for larger font, voice assistance, and consumable color themes. Integration with wearable device such as smartwatch to automate vital signs, recording, and improve real-time health tracking. The third one, expand platform supports because we made the application Android, so maybe we also can improve to iOS users. AI-based health analytics. We can also add AI to our application, so the AI can also detect anomaly, maybe how to alert caregivers of potential health risks earlier. And last one, scalability and security improvement, strengthening encryption and compromise with health data to protect users' data. And last one, next. Acknowledgement, we would like to express our deepest gratitude to Maranatha Christian University. Special thanks to Faculty of Smart Technology and Engineering, particularly for the computer engineering study program. And also we would like to gratefully to Faculty of Humanities and Creative Industry, especially the Visual Communication Design study program. Thank you.
Okay, any questions? Yeah, please. Wait here. Wait.
Thank you. My name is Teguh. The first one, I think you have a development application and then you use SUS, usability testing, for the user experience. Is that it?
Yes.
Yeah. So from your development to be released and then user experience, how long this the time to be from the release to be user experience?
Please give me a moment.
Sorry, if you have less than 6 months, maybe or you have to about 1 or 2 months from your release, I think this is the suggestion for your paper. I think you have to not use usability testing, but use acceptance test. The first you have to that is the first your paper, and then after 1 year you can use your usability or user experience. This is your paper. I think it can be split to be 2 paper. Thank you.
Okay, thank you for the critics, sir. So for the application, we took 3 months, but unfortunately the application is still not online, and we just chose 15 participants and asked them for help for the usability for the testing. Thank you for the critics, sir.
Yeah, thank you for the suggestion. Any other question? Okay, if not, give applause for them. Thank you. Okay, now we go to the third speaker, which is me, myself. So I will deliver. My topic is about the evaluating urban livability through the aesthetic and environmental index, a special framework for Bandung City. My name is Robi Yusaktalar. I come from the Department of Civil Engineering, but I have a lot of friends here, come from the other department. Next. Okay, the contents today is about the introduction part, literature review, the methodology, and also, of course, the last is the conclusions. Next. We understand that Bandung City is a very complex city. So we have so many problems here. So one of them is the flood. And how about the city of Bandung is in the other perspective? Sometimes I, as a civil engineer, I don't consider about the other people perceptions. But now I try to understand if you are as the
design people or as the other background. So this is the things that I want to combine and I want to collaborate. And we also understand in Bandung, we have such a rich heritage and the colonial architects here. But still we have the problems like the physical development and the preservation aesthetic value in the city. Next. Okay, then the other topic is about the visual beauty. Talking about the sustainability, in the civil engineering perspective, we just consider how to maintain the buildings or the structure itself. But now I also try to grab the value of the aesthetic value itself. And that also will consider the sustainability. So this topic or this paper, I try to explain about the aesthetic environmental index and the integration among 4 parameters: population, green open space, temperature, and the natural disaster adjust the weight. Next. Talking about the aesthetic environmental index itself and the livable cities now. Next. We have the concept that includes 3 dimensions. The first is the visual aesthetics, consists of the layout, architecture, and the open space. And the second one is the environmental comfort, like the air quality, noisy, and sanitation. And the third one is the accessibility of public facilities. And this meets the high AAI criteria correlated the community satisfaction. So the point is we have the subjectivity that need to be considered here. And also, in fact, the availability of the green open space, about 20% of this area, is already mandated by the law in number 26, year 2007, is proven to increase the ecological resilience. Next. And we also try to have the creativity in the context of the urban environment. Next. And this is the literature review. The definition of the creativity itself and the theory, and also some previous study revealed that the people perception of the unconventional dressing styles and still considered unprofessional, and the other fact. Next. I try to grab the fashion as the component of the sustainable city identity now. Next. And the fashion industry also contributes not to for economic value, but also the city of image. So in Bandung, we have several shop or distro that provide kind of this fashion products, and also the growth of industry should be in line with the sustainability. Next, the methodology that we try to use is the first is the literature study, and the second step is the data collection here, and also we select Bandung City as the study area, and also we choose 4 parameters here and do some weight and visualization. All these steps is considered by the GIS, spatial analysis approach, and also we use the important performance analysis to visualize the relationship. Next. And this is our study area. We now in the Bandung City, we already have 30 sub-districts based on the regulation. And this also will be focused on the policy maker and can provide the better solution and understanding to the result and the resolution. Next. Actually, the development of this index is divided by 2 divisions. The first is the environment, and the second one is the aesthetics value. So the environmental parameters, we choose the temperature and the frequency of natural disaster. So we collect the data from 2018 until 2020, and we record also several floods event here, and so on. And also we divide it by several land use types. Next. And for the temperature parameters, we also have 3 classification. And maybe if you feel today in Bandung is not quite hot, so the temperatures around 20 until 22.8 degrees Celsius. Next. And for the aesthetic parameter, we choose the green open space for many functions, such as recreational, socio-cultural, aesthetic, physical city, ecological, and so on. And also the population growth here. Next. And this is after we analyze, we have two main parameters and the variables. We also have the classification with the description itself and the weight itself. This table or this classification is only for Bandung City. If you want to compare or what you want to develop in your own city, maybe you need to develop based on the characteristic of your city. Next. And this is the result. We have diagram relationship among the aesthetic and the safety. So we have 4 quadrants here, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And of course, in the quadrant 1 is low aesthetics and low safety. And in quadrant 4 is the low aesthetics and the high safety. So the good one is the quadrant 3 is the definition is the high aesthetics and the high safety. And then next, the result is after we do the analysis by using the Landsat 8 until 9 operational land imager and the thermal infrared sensor collection to level 1 data and then the data process in the year 2025. This effort also involved the TOA radiance, and also we calculate by the brightness temperature and also use the NDVI and the land surface emissivity. We already found that the 3 sub-districts in Bandung City, especially in Bandung Kidul, Bojong Loa Kidul, and the Regol, has the lower temperature compared to the other sub-district in Bandung City. So if you now stay maybe in Maranatha, we are not in Bandung Kidul. So this is not, I mean, the temperature is not too low compared these 3 areas. Next. Other result is that we also compile based on the green open space availability and the building density using certain tools here, and then also we get the result. Next, the result is you can see in the figure. Quadrant 1 is the not a good one. So if you are stay in Archamanik, that's the bad one. So it means that the quality and also the temperature is, maybe some of you stay in Archamanik. Good luck for you. But the green one is good one because we are live in the quadrant 3 here, which means the aesthetic is still good and also the quality of life is also still good. Lucky for us, Maranatha maybe in the green or in the yellow one. Okay, next. Jump into the conclusion, like I said before, I want to compile or to collaborate between these 4 parameters and to see which area is the best for us to stay in Bandung City. And again, we have something for the recommendation for the government itself. For example, if the government want to build like the recommendation to build the parks or the green infrastructure area, we suggest they can provide for the certain area in North Bandung area. And also I hope the government have the real-time monitoring and participatory governance here. Next. Okay, some conclusion also the environmental parameters is consist of the temperature and the disaster. Meanwhile, the aesthetic parameters consist on open space and the built density. It means that some of area is most of our city is fell in the quadrant 2, which means that it high aesthetics and the low safety. Some area may be good in aesthetic value, but still not safety for us. Next. Okay, this study also used the spatial disparities and livability, and in South Bandung City, we can target the expand green corridors and the pedestrian infrastructure also here. And also the government can build a pilot livability area here by integrating, again, the green infrastructure. There are so many components for the green infrastructures. For example, like the vertical garden in the commercial area or the water retention. Like now we have so many rain, so the problem is the flood. So if we don't use the green infrastructure concept design into our city, especially in Bandung, so we still have a flood problem in Bandung City. Next. Okay, again, thank you very much. And if you have any question, please. Okay, now we go to the fourth speaker. Let me read the title first. The fourth title is about the transforming religious and cultural heritage through the digital tourism, a competitive strategy canvas approach in Kupang, Indonesia. The speaker is Dr. Yola Margareta. She's come from Maranatha Christian University. Now the time is yours.
Thank you, Prof. Robi. Okay, guys, are you still excited about this? Good morning. Wow, still sleepy? Okay, so today I will present about our paper. Wait a moment. Yeah. Today we are pleased to present our joint paper, authored by four for us, Yola Margareta, Elizabeth Yuanto, Cindrawati Lesmana, and Prof. Maya Malinda. And the title is Transforming Religious and Cultural Heritage Through Digital Tourism, a Competitive Strategic Canvas Approach, CSC, in Kupang, Indonesia. As digital tourism involves Kupang's religious and cultural heritage, encounter both challenges and promising opportunity. This presentation highlights how the competitive strategy canvas can reveal Kupang's current position and guide strategic digital innovation to strengthen its attractiveness and sustainability. Okay, next. Background and objective. In this slide, I will explain the background of the study. Kupang has rich cultural and religious heritage, such as historic churches, traditional houses, and weaving tradition, and also colonial era sites. However, these assets are not fully utilized due to weak digital marketing, fragmented management, and limited strategic positioning. Based on this context, our objectives are twofold. The first one, to assess the current condition of Kupang's cultural and religious tourism using the CSC format bites framework. And the second one is to propose practical and strategic recommendations to strengthen competitiveness through digital technologies and stakeholders' collaboration. Next. This research used a qualitative exploratory case study designed to deeply understand the dynamic of tourism in Kupang. We collected data through interview with church leaders, cultural community leaders, artisans, tour operators, and tourists. We also conducted field observation at major heritage sites and reviewed tourism documents and policies.
To analyze the data, we applied the competitive strategy comprise combined with the 11 elements of format bytes and enabled to use systematically map strengths, weaknesses, and strategic gap. Next. This one, our field observation. The first one is Aldous Church in Kupang. And the next field observation also in Beto Osapa Church. Next. And Maranatha Soe Sonhala Niki Niki. This is kind of the church. And Getsemani Bao. Next. And also traditional houses in Soe and Kupang, we call Sonaf. And weaving centers. Yeah, you can see at the picture that women do some weaving. Okay, next. Format bytes framework. It stands for 11 strategic development elements, from focus and operational efficiency to innovation, marketing, and strategic partnership. By using this framework, we were able to evaluate not only the marketing and operational aspect of tourism, but also talent development, agility, and partnership, which is essential for long-term competitiveness. Next. Our analysis identifies several strengths and challenges. The main strength is Kupang unique differentiation. The combination of religious heritage and cultural traditional offers an authentic and irreplaceable tourism experience. However, several challenges were found. The first one is digital visibility is still low, and promotion activities rely heavily on local network. The second one is operational process across sites are fragmented and not integrated. The third one, talent in digital literacy and hospitality is limited. And the last one, there is no structured performance monitoring and benchmarking system. This is a gap limits Kupang ability to compete with other cultural destinations. Next. And we jump into conclusion. Conclusion based on the findings, we formulated several strategies for recommendation. And Kupang has strong differentiation based on its rich cultural and religious heritage. However, to unlock its full potential, the region must focus on improving the digital adoption, operational efficiency, and talent development. The CSC format bytes framework provides a structure and holistic roadmap to strengthening competitiveness. We recommend future research to apply this framework to other heritage destinations and incorporate quantitative indicators such as tourist satisfaction and economic impact. That's all. Thank you.
Any questions? Anyone? No? Thank you, Dr. Yola. And next speaker is the title is The User-Centered Approach in Designing Smart Homes, the Effect of IoT Technology in Emotional Design of Smart Living. Please come forward. The speaker is Mr. Boyke Ansori from Pradita University.
Hello, tes. Okay, thank you. Good afternoon, everyone. I'm Boyke Janus Ansori from Pradita. I will introduce context in the user-centered approach in designing smart home. Is the title is smart home in the design of the smart living environments. Maybe the use from the linear research with my program study interior design. Next slide. And the context is the how about to keywords user-centered design and IoT and emotional design approach for the interior design, because the interaction in the smart living is the use from us is the initial from the designing smart home with the emotional approach. And then the challenge and the future direction is IoT technology, its influence and emotional design. Next slide. The rise of the Internet of Things has transformed domestic environment into responsive ecosystem, and the study actually investigate user-centered approach in the smart home design and examine how IoT technology influence the emotional experience. And then the finding reveal the degree of user satisfaction and emotional connection. Actually, is the smart home correlate with strongly with the perceived control, personalization, and system transparency. Emotional design principles, specifically effective attachment and usability mediate, and this research contribute the growing field human-centered by offering integrative. Next slide. And the user-centered design smart home, we can explain. Next slide. Part of the three understanding user-centered design. The first is definition and important. The context, the user-centered design focus on the creating smart home that meet user needs and emotion, and making technology easily enjoyable and helpful in daily life. And the second is principle user-centered design is the focus in the ensuring smart home is usually enjoyable by need, preference, and emotion. And the third is relevant the smart home. The use the adapting technology in the real life habit and emotion is something like that. And the next slide. And the role of emotional design is the three parts. The first is the concept of emotional design. The second is user experience and emotional connection. And the third is impact on user satisfaction and engagement. And all of the explained is the conclusion is user experience is the smart home shapes how people feel and connect emotional with the environment, and making technology feel more personal, comfort, and enjoyable to use every day. Next slide. And next slide. And this the overview is the three parts again: IoT components, and second connectivity and data integration, and the third is example of the IoT device of smart home. Next slide. Emotional design, the adapt from the feedback and sensing technology is the part for adaptive responsive. The affect is the user, and then the responsive with the IoT integrated, and the environmental adapt, and then the response is the important is the response the IoT and the back to user again in the smart environment. And the personal user experience is the let smart home learn your habit to create, and then making space feel more comfortable and connect to your daily life. Next slide. Next slide. And the methods of the involvement in design is the three part is the user research, usability, and participatory design technique. In the three point is the usability testing lets user the try smart home, and then helping designer improve comfort and emotional connection in smart living. Next slide. And the integrating actually is the aesthetic and sensory, creating comfort and supporting well-being, mood regulation. It's important the mood regulation, because the adjusting lighting, temperature, sound, creating comfort is the more the use the one connect with the IoT. The next. And the challenge and the future direction. The next. Addressing the security concern is the with the data protection in smart home and balancing transparency and ethical consideration. Is the 3 point is the related and using emotional data race, ethical use like consistent and privacy and potential requiring clear. And the last slide, ending. Okay, ending.
Okay, give. We have this
Next
one.
slide. Synthesis, conclusion. Integrating these three areas, cultural variation, multi-user dynamic, and then conversely, when design overlook this factor, it can lead alienation, confuse, or digitally in quality within the household. And then ensuring that smart home is the future is not only intelligent but also inclusive, empathic, and deeply human in its understanding of the diverse way people live together. Next slide is the thank you.
Yeah, give applause. Thank you very much. Any questions?
I hope it's clear.
Okay, then now thank you very much again, Bapak Boyke, and then we go to the other speaker. Okay, the title is the Optimizing User Experience at a Fresh Dental Care Clinic, Usability Analysis, Testing Analysis, and Efficiency Improvement. Please come forward, Bapak Teguh Prasandi from Binus University.
Thank you for the moderator. Give me time to present this paper. This paper is optimizing user experience of Fresh Dental Care Clinic website using usability testing and with PLSM. Ardila, Artikasari, Yogi Iswari, and Prasandi. The next slide. Digital health services increasingly rely on website to provide information and support online appointment booking. BF Fresh Dental Care Clinic use a website as a primary touch point for patients to explore treatment, check doctor availability, and plan to visit. However, some users still experience difficulties when interacting with the website, especially when searching for sustainable doctor schedule and making an appointment. This issue indicates potential usability problem that may affect overall user satisfaction. Okay, next. This is the research problem. How usable of Fresh Dental Care Clinic website from the user perspective, and then how do the key usability dimension influence user satisfaction. Okay, next. This is the research objective to evaluate user perception of 5 usability dimensions on Fresh website: learnability, efficiency, memorability, error, and satisfaction. To analyze structure relationship amongst these dimensions using Smart PLS. To propose interface improvement with a focus on doctor schedule page and appointment related tasks. Okay, next. Next. The website usability is through 5 dimensions is learnability, efficiency, memorability, error, and satisfaction. learnability have connecting to efficiency, learnability to memorability, efficiency to satisfaction, error, and to satisfaction. Okay, next. This is the research methodology that we use. Population is about 5,000, is about 6,000. And we have sample with 100 respondents. We use 10% margin from formula from Slovene. Data collection, we use online questionnaire with 50 items. 8 usability dimension, measure 10 Likert scale 1 to 0.5. Data analysis, we use SAM modeling with Smart PLS. Next. This is the respondent profile, 40% male, 60% female, and we groups to be 70 to 20, 21 to 23, 24 to 28, and etc. Okay, next. Next. This model result, our construct is a good consistency that conval alpha is composite reliability is more than 0.70. Convergent validity is achieved, and average variance AVE is more than 0.5 for construct. Discriminant validity confirm for local criterion that overall is perfect. Next. Structural model explain that X square learnability explain is more than satisfaction. The effect is learnability, efficiency large effect, learnability probability large effect, error satisfaction medium effect is more than F2 is about 1.168, efficiency to satisfaction is small effect. And with this, efficiency to satisfaction will be improve the user interface. Next. This key finding of interpretation, I think will be next. This is the design. The previous design is called to long list on doctor schedule, manually search for sustainable time slot, and navigate limited filtering option. The new redesign is rich search filter, branch, day, time, doctor practice hour, etc. Clear grouping of doctor and schedule information, more consistent navigation between page and section. Next. This is to the imitation. This is a single site case study, one of dental clinic website in Indonesia. Online survey with self-reported perception. Sample dominate with younger and female user. The model include 5 usability related construct, and the redesigned interface has not yet been tested through follow-up usability study or experiment. Next. The future research is empirically test redesign doctor schedule, page using A or B testing or pre-post evaluation, combine subject perception, extend model with additional construct, conduct comparative across, explore personalization. Next. This is the conclusion. The usability PFS dental clinic website is strongly influenced by learnability, low error level, while efficient play group supporting full but smaller role, and user value clear, predictable interaction, and easy use to understand interface more than speed alone. Next. Okay, next. This is the acknowledgement of this paper. We will say to be a fresh screen for the support and the permission to conduct the study, and the author, please before, And the author also announcement use ChatGPT, OpenAI as a writing assistant tools during revision process the manuscript and presentation. Thank you. Next, thank you. I will give you back time to moderator.
Thank you. And we have a question here? No? Okay, give applause one more time for the presentation. And we have, the last one. The topic is the early warning models for predicting students' performance in programming courses using admission and early assessment data. Please come forward. Joanna Adityanti Mita Nugraha from Universitas Atmajaya, Yogyakarta. Give applause.
Okay. Good afternoon, everyone. My name is Joanna, and today I will present my study on early warning models for predicting student performance in programming courses using admission and early assessment data. Next. Okay. Programming courses often show the highest failure and dropout rate in computing program. Many studies struggle due to weak mathematics foundation, limited problem-solving ability, or challenges adapting to computational thinking. Traditional early warning system rely mostly on historical grades or midterm score, which are available too late. This motivated or effort to explore predicting modeling based on early admission level signal. So, while many studies use learning analytic for prediction, most depend on LMS interaction log or mid-semester grades. Very few focus on the admission level variable combined with early formatic assessment. There is also limited research addressing how to build reliable prediction model when institutions have small data set, typically fewer than 100 students per year. We aim to bridge these two gaps. So the goal is this study integrated admission data with early assessment data with quiz and assignment. Next. Okay, the research objective and contribution. My study has three main objectives. The first one is evaluate model logistic regression and random forest in identifying at-risk students early. And the second is compare admission versus early assessment feature. And the third is use cross-validation and bootstrap for robustness, because my data is very small, just 67 for data. Okay, next. Okay, this is methodology for data and model. I use just 60 first year programming student in my class. So I use admission data, mathematics, English, and Indonesian for admission office, and I combine with early assessment in my class is assignment and quizzes in week 3 and 5. So target variabelnya course completion status label that I use is 1 for pass and 0 for fail. So model selected that I use is logistic regression and random forest for see the early student risk. Next. Next. Yeah. Because my data is very small, in 67, I use evaluate two robustness methodology. The first one is stratified trend test split, maintenance class proportion, file pass and fail distribution, and the second is 5-fold cross validation, reduce sampling variance by average model metric across multiple fold, and the third is bootstrap CI, used to estimate 95% CI for accuracy, F1 score, ROC, and crucial for small sample inference. Okay, next. Okay, the key finding to predictive power, early assessment variable to assignment and quizzes were the strongest predictor of programming success, surpassing all admission test score. And logistic regression coefficient, the quiz is the stronger positive predictor. And then assignment, the second strongest, and math score is moderate positive effect. And then predictive accurate improve after week 5. Okay, next. So this is a difference from logistic regression and random forest. And the table for accuracy, logistic regression is highest than random forest. Test accuracy, ROC, bootstrap, all of metric, logistic regression have the highest score from random forest. Okay, next. Okay, this study used to practical implication for institution. The first one is academic monitoring. Institution can operationalize result into an early warning dashboard that automatically flag student at risk within the first week of class. And the second is timely intervention. Instructor can deploy model-driven alert to trigger performance feedback, remedial session, or personalized guidance before failure become inevitable. So this, the third is curriculum design, finding underscore the need to embed low-stake formative assessment, such as quizzes or assignment early on, serving as a continuous diagnostic tool. And the last is poly-science strategy in this institution. Okay, next. Okay, this is the conclusion, combining pre-entry data and early semester data, evidence produce actionable insight on and offer a practical, scalable solution for real-time academic risk monitoring, and the use of robust three-tier validation because the data is very small. Model calibration effectivity mitigate variance often associated with small education data set. This approach paves the way toward more equitable. Okay, next. Okay, for the future work, we hope there is dynamic early warning system, implement adaptive model that update risk probability in real time. And the second is research feature incorporate behavior log data, LMS activity, or code submission. And the last is explainable AI, employee shape or LIME framework to further enhance interpretability for educator. Okay, thank you.
Thank you. Any question? No? Okay. Before we close our session, we need to come forward to take a picture first. So please come to the stage and someone will handle and arrange our session. Okay. All the speakers and all the audience, please come forward. Bu Maiti, gabung? Nggak apa-apa kayak ya. Ya. Dokter Yola. Ayo maju. Iya ini biru-biru. Ini aba-abanya gimana? Ini oke. Ini saya nggak pakai mic ya, kamu atur ya.